my cute cuties. Are you guys there? Yes. Hi, Hemapriya. Yes. Let us start the session. So, எல்லாருமே எப்படி இருக்கீங்க? Happy-ஆ safe-ஆ இருக்கீங்களா? Everybody tell me. Happy-na give me a heart. Safe-na give me a thumbs up. Yes. Agash, right? Agash, if I'm not wrong. Yes, Agash, I'm good. Yes, Hemapriya, I'm good. Happy because I got a chance again to teach you people. So, adinala vandu I am very much happy. So, in the session la, we know that we are going to cover 3 chapters, okay? Adila first one the dual nature of matter, radiation, and then second one the atom, third one the nuclei. So idu da inneki what we are going to do. So ippave you can do one thing, you can like this video, also share your maximum, okay? You can just share this video with all your friends. Together we are going to study. I'm promoted to 12th class, okay. Very good. So, as I mentioned, you can share this video with your friends. So, quickly in 2 minutes, we are going to start the session. Okay, in 2 minutes, we are going to start. We will be starting with dual nature. So, adukku munnadi max to max all your friends ku vanda in the video share panniko. Okay, yena vantu powerful we are going to finish this chapter. In the chapter as you guys know, simple we are going to get the marks. Yena idu kuda weightage vantu it is high and easier score panna mudiyum. So idula vandu each and every topic in the dual nature, atom, nuclei la vandu what are the topics we have to be focused. Also NCERT la each and every line we are going to we are going to find the loopholes and we are going to study. Okay, semiconductor we will do it as a separate chapter. Yena vandu inneki in the session 5 hours dana, in the 5 hours la we can't finish the whole, so adanala we can do it on some other session. Okay va? Okay, ready na? Give me a fire in the chat box everybody. Arambikkalama? Are you guys all ready? Ready na? Give me a fire. Yes. So gosh, I hope you are a new student, right? Yes. Okay, very good. So as I mentioned in the chapter, first one we are going to deal with the dual nature of radiation and matter. Dual nature of matter, okay, and radiation that we are going to discuss today. So idala vandu first thing we should understand. Okay, we should understand the basic idea. Basic idea na ennada? Very simple. In the light ku 2 properties irukku. Idu vandu it will act as a wave as well as it is having particle nature. Light ku vandu 2 properties. Adudha vandu in the chapter oda name dual nature. Light ku vandu what is happening? It is having both the one important thing. Adu vandu nothing but our photon. Okay, we should know about our photon. So in the photon na enna? So ipo vandu as I mentioned, in the light ku vandu particle nature irukku. Adil irukra in the particle da, okay, in the particle da nothing but in the photon. I can say that idu vandu oru energy packet. Okay, idu vandu oru energy packet. So right now the thing is like in the photon vandu can we see this photon? Illa. Yena idoda speed vandu in the photon vandu always it will move in a straight line, and in vacuum idoda speed vandu 3 into 10 to the power meter per second. So ipo vandu understand we are talking about the photon. So in the photon oda speed vandu equal to the light, okay, and it will always move in a straight line. அப்படினா இந்த photon I'm going to catch this. Okay, இந்த photon பிடிச்சு we cannot check its mass. Okay, so அதனால we are considering, okay, we are considering இதோட rest mass வந்து 0. Okay, இதோட rest mass we are considering it as 0. Okay, so usually வந்து இந்த modern physics ல இருந்து we can expect up to like 8 questions. Okay, அதுதான் as I mentioned high weightage தான் and அதுக்கு அதோட ஈஸியா ஸ்கோர் பண்ண முடியும். Okay, அதுதான் இந்த சாப்டரோட அட்வான்டேஜ். புரிஞ்சுதா? ஸோ இப்போ வந்து இது வந்து ஸ்ட்ரெயிட் லைன்ல தான் மூவ் பண்ண போறேன் அண்ட் இதோட ரெஸ்ட் மாஸ் வந்து நத்திங் பட் 0. இம்பார்ட்டண்டான 2 பாயிண்ட்ஸ் தான். நெக்ஸ்ட் வந்து இந்த ஃபோட்டோனை we can feel it. ஆனா வந்து இந்த ஃபோட்டோனை we cannot touch, we cannot see. Okay, whatever we can say is in the photon we can just feel it. And in the photonக்கு எனர்ஜி இருக்கு. அந்த எனர்ஜி தான் h mu. Okay, h னா Planck's constant. Okay, h னா Planck's constant. அதோட வேல்யூ கூட we know it. What is the value? அதோட வேல்யூ வந்து 6.6 into 10 to the power minus 34 தான் இந்த Planck's constant ஓட வேல்யூ. Okay, ஓகேவா? So Planck's constant ஓட வேல்யூ வந்து 6.6 into 10 to the power minus 34. Next வந்து இதே the same value you can just go in terms of electron volt. Okay, so இதெல்லாமே வந்து it will be helpful during the exam time. Okay, so இந்த values வந்து நீங்க வந்து chapter வந்து ஈஸியா you can just start with your 9th grade. Okay, so proper வந்து மனோவா right, proper வந்து if you are just starting your 9th grade chapters. Okay, ஏனா வந்து இப்போ வந்து you have completed 10th, correct இல்லையா? so அதனால you might have forgot the 9th grade chapters. so first வந்து you should revise that. ஏனா அதோட continuation தான் இந்த 11th gradeல. so once you have to crack the 9th grade chapters, அதுக்கப்புறம் come to the first few chapters. அதோட இம்பார்ட்டண்டா you can better go for the mathematics part also. ஏனா physicsல till this 10th grade you are not dealing much with the mathematics in physics. ஆனா 11th ல 12th ல we need mathematics. Even if you are not a math student also you should know. so அதனால you can just go for that also. It will gradually increase your confidence. Right now again, so இப்போ வந்து energy we got it. Okay, so இந்த எனர்ஜிக்கு we can also say இதோட velocity வந்து c. velocity வந்து c. அதனால I can say it is nothing but equal to hc by lambda. Okay, okay வா? புரிஞ்சுதாடா everybody? Okay, what I have written? Oh sorry. Okay, sorted. Okay, so இதுதான் வந்து unit. I have written it as joule per second. Okay, so இப்போ வந்து you got to know in the we understood இந்த photonக்கு வந்து energy இருக்கு, momentum இருக்கு. so அதோட value தான் h by lambda, or let's say you can go for e by c. next important ஆன ஒரு point என்னன்னா, okay, இப்போ வந்து as I mentioned இந்த energy h mu தான், கரெக்ட்டா? இந்த energy வந்து h mu தான். அப்படினா இந்த energy can I call it as kinetic energy? Can you give me the answer? Okay, those who are watching tell me. இப்போ வந்து energy h mu, can I say இது வந்து kinetic energy of photon? Can I say that? Give me yes or no. எனக்கு வந்து can I tell that this will be coming as the kinetic energy? Yes, coming to that, let's wait. Okay, no. Okay, இந்த energy of photon வந்து not equal to kinetic energy, not equal to potential energy. இது வந்து call it as the internal energy. so the thing is like in the photon we cannot handle like the way we have handled electron and proton. Okay, so அது வந்து particles, proper we know the particles in the electron, proton, அதுக்கு proper mass இருக்கு, charge இருக்கு. so இதுக்கு வந்து charge னா neutral தான். Okay, இதோட charge வந்து neutral தான். ஓகேவா? so இப்போ வந்து you should understand இந்த ஃபோட்டானோட எனர்ஜினா அதோட இன்டர்னல் எனர்ஜி தான். அதுக்கு வந்து கைனெட்டிக் எனர்ஜி, யூ cannot say that h mu தான் இதோட கைனெட்டிக் எனர்ஜி or h mu தான் இதோட பொட்டென்ஷியல் எனர்ஜி. அது வந்து ராங் தான். புரிஞ்சுதாடா? இம்பார்ட்டன்டான பாயிண்ட் தான். when I'm talking about energy of photon, and the energy of photon என்னடா? Can you give me the answer in the chat box? Energy of photon na enna? Give me the answer in the chat box, everybody. Energy of photon na, give me the answer in the chat box. Yes, very good, very good. Adudha vandu what we are calling it as the internal energy. Also, we said in the charge vandu neutral da. Adanala we can also say this will never deflect in electric and magnetic field. Okay, another important point da note panniko, in the photon you should know in detail. Okay, adukapram da once we are starting with photoelectric effect and all, you will be getting a clarity. So ipo vanda in the photon proper introduce பண்றது da first thing. So adula vanda we understood idukku idu da in the waves la particle behavior. Okay, so idu vanda energy packets da, and the energy vanda h mu da, and also we can say that in the energy vanda adoda internal energy da. Okay, so adukapram we know that adoda rest mass vanda 0 da, and adoda momentum vanda h by lambda da, charge vanda neutral, adanala it is not going to deflect in the electric and magnetic field. Purinjidada? Purinjidichina? Give me a fire in the chat box quickly. You can just give me a fire in the chat box. Adukapram we can just go for the equivalent mass. Rest mass vanta 0 da. Right now we are going for the equivalent mass. Yes, perfect. So let us go for the equivalent mass of this one. Okay, va? So as we know, energy is equal to mc square. Appadina I can say that m is equal to E by c square. Can I say that? So appadina in the E na h mu divided by c square. Again in the h mu kaga I can write c by lambda. Appadina I will be getting h by lambda c. So in the equivalent mass vanda you can write in different format. M is equal to E by c square. E na h mu by c square. Adukapram mu we know it is nothing but velocity by wavelength. So velocity of the photon vanda c da, so c divided by lambda. Purinchidada everybody? Yes or no? Yes or no? So appadina we can just you can just solve a question. Ready ya? Quicker we can go for a question. Yes. So idala vanda find the number of protons. Okay, you guys have to find the number of protons in 6.63 joules. Okay, va? Number of protons, I was just missed. Photons. Okay, number of photons in 6.63 joules of radiation, and idoda frequency. Okay, idoda frequency kuda it is given. We need to find the number of photons. Adoda energy vandu 6.63 joules da. Adoda frequency vandu 10 to the power 12 hertz. Purinjida? We need to find the number of photons, and energy vandu it is given 6.63 joules, and frequency kuda it is given, that is nothing but 10 to the power 12 hertz. Appadina in the number of photons enna? As we know, in the energy na total energy na, it is nothing but the number of particles, number of photons into h mu. Correct? So ipa vandu we know energy of photon vandu h mu da. So total energy vandu ipa vandu 5 photons irundiruchunu, I mean if there is 5 photons, okay, appadina we can say the total vandu 5 h mu. இப்போ வந்து 10 photons இருந்துச்சுன்னா total energy வந்து 10 into the energy of one photon. அதனால தான் I have written it as n into h mu. இப்போ வந்து you can just do one thing, energy divided by h mu will be giving you n. So right now energy na 6.63 divided by h oda value 6.63 into 10 to the power minus 34, frequency வந்து 10 to the power 12. So இது வந்து cancel ஆக போற, and what we have after that, we will be getting the 10 to the power 22 as the number of photons. Very good Akash, very good, very good. Okay, quicker you have given the answer. So we can also expect this kind of question using the energy, the total energy of the light. Okay, total energy of the light na, it is nothing but number of photons in it into the energy of one single photon. Purinchidada everybody, yes or no? Please let me know in the chat box everybody. Okay, so next one the important ana oru thing da. Okay, yena vandu whatever we have studied right now, okay, whatever we have studied right now, neenga vandu CBSE syllabus la kuda you must have studied. Next vandu another important topic, adu vandu nothing but the radiation pressure. Okay, radiation pressure. என்னடா இந்த radiation pressure, என்னடா இந்த radiation pressure? மறக்காம லைக் பண்ணிக்கோ guys, everybody, those who are watching. And also let me just tell you, நம்ம நம்பிக்கை batch வந்து 16th க்கு launch ஆக போற, and tomorrow there will be a launching session as well, so you guys can attend that session also. இப்போ வந்து NEET க்கு 2026 NEET க்கு வந்து அவ்ளோ அந்த லெவலுக்கு prepare பண்ணனும் மேம் அப்படினா இந்த நம்பிக்கை batches for you people. Right now you can just check it in the description box, அதுல link இருக்கு, you can check it out. ஓகேவா? So இப்போ வந்து radiation pressure. So in the radiation pressure na very simple concept da. Okay, so right now the thing is like, I can also say this light can actually push the object. Okay, this light can push object. So adakaga it will exert some pressure, right? So on the light exert pandra on the pressure da in the radiation pressure. Okay va? So what is radiation pressure? It is nothing but the pressure exerted by light. Okay, pressure exerted by na in the light ku actually vanda it can push the object. Even in space, in the spacecraft vanda due to sunlight it will move. Okay, important thing da. Okay, in the spacecraft illaya idla vanda using sunlight, using that radiation pressure, it can move. So அப்படினா இந்த radiation pressure da next வந்து we need to handle. Okay, so right now we know that I'm going to introduce a quantity, intensity. Okay, intensity na enna? Energy by time per unit area. Correct? அப்படினா this is nothing but the total energy. I can say the number of particles or number of photons into energy of one photon divided by area into time in the intensity. Correct? Simply we have started with the intensity equation. Intensity equation na enna? Energy per unit time per unit area. அப்படினா இந்த energy இது வந்து total energy da. We have mentioned in the total energy na enna? Yes, idla வந்து 5 particles இருந்துச்சுனா 5 into h mu. h mu na enna? அது வந்து இந்த photonோட energy. புரிஞ்சுதா? அப்படினா I got n is the number of photons. I mean each and every line you should copy in your notebook, ஏனா இதெல்லாமே வந்து important. Okay, next வந்து EP the energy of single photon. Okay, so அப்படினா I will be getting this equation. A na area, T is nothing but time. So இதுதா வந்து இந்த basic equation. Right now I'm just asking you in the energy by area, sorry, energy by time. Okay, energy by time. Can you just tell me what is energy by time? 9th grade question da. You can just give me the answer. 9th grade question. Energy by time na enna? Energy by time. Simple, power da, correct? So, அப்படினா I can say N into P divided by area. Okay, right now I got the equation as N into P divided by area. அப்படினா I can say P is nothing but power. Okay, confuse ஆகாத ஏனா வந்து pressureக்கு கூட we are going to represent it as P. அதனால yes, perfect. Okay, அதனால mention பண்ணிக்கோ each equationல terms வந்து mention பண்ணிக்கோ. இதுல இந்த P வந்து nothing but power. Okay வாடா? So அப்படினா I'm going to ask you. Okay, the intensity due to point source. Okay, intensity due to point source. Right now we know N into P divided by area da in the equation. So point source na adila in the area வந்து 4 pi r square. Next வந்து linear source. Okay, இப்போ வந்து இது வந்து linear source na it will be NP divided by 2 pi into r. So in the equations you should know. Okay, இதுக்கு வந்து நியூவா we are not going to study anything. In the point source na அதுக்கு வந்து அதோட dimension we will consider it as a sphere. அதோட area வந்து 4 pi r square. And linear source na we will be consider the curved, the area of the curved surface. அது வந்து 2 pi r. Okay va? So இதுதா வந்து you should know it, the intensity in terms of power. Okay, so in the equations kuda important da, you should mark it as important. Okay vada? Next vandu, can we go for the expression for radiation pressure? Are you guys ready? Ready na? Give me a fire. Okay, in the chat box vandu avlo weak kareka vai. Usually vandu I used to get energy from the chat box. Ana inneki vandu weak kareka. What happened to everybody? What happened? Let us go for radiation pressure. Okay, so we are going to find the expression for radiation pressure. Okay vada? So idhula vanda, thank you Hema, thank you. So ipa vanda in the radiation pressure illa, yes. Darshini, hi Darshini. Okay, so radiation pressure la very simple. According to Newton's second law, can you just tell me what is Newton's second law? Simple, can you give me the expression in the chat box? Newton's second law. Newton's second law, what is actually the meaning of Newton's second law? The force is due to the rate of change of momentum. Correct? The force which is equal to rate of change of momentum. Idhila vandu in the P na momentum. Force oda equation da. Okay. Rate of change of momentum. Adanala in the P vandu what is our momentum da. Previous case la intensity equation la P vandu power da. Correct? Note panniko. So idhila vandu, let us say we have a reflecting surface. In the wave vandu hitting on the surface and it is going back. Okay, so idoda momentum vandu h by lambda na, idoda momentum vandu minus h by lambda. Yena direction change aachu. Correct illaya? Ipo vandu we are projecting a particle with a velocity v. Okay, it is coming back with the same velocity na, adula change in momentum enna, which means here we have a surface, we are projecting it with a velocity v, and after this it will come with a velocity v. Appadina idhula delta p vandu nothing but what to say, m into, or let's say we can say 2v. Okay, m into 2v da idoda change in momentum. Correct? So now you guys have to tell me, in the case la what is going to be the change in momentum? In the case la vandu what is going to be the change in momentum? Very simple ma'am. Idoda final momentum minus initial momentum. So final momentum in the direction vandu I am taking it as positive. Okay va? Appadina I will be getting h by lambda minus in the direction vandu negative. Appadina I will be getting minus h by lambda. So this will be coming as 2h by lambda as the change in momentum. Right now I'm just writing 2h by lambda into 1 by t. Purinjudada? Okay, so இப்போ வந்து what we got the expression for force. இப்போ வந்து சின்னதா I'm going to do something very simple. I'm going to multiply and divide with C. Okay, இப்போ வந்து I'm going to make some rearrangement. பார்த்துக்கோ, 2hc divided by lambda into 1 by ct. அப்படினா you guys have to tell me in the hc by lambda na enna? hc by lambda, have you studied this, yes or no? In the hc by lambda enna? hc by lambda enna? Can you tell me the answer? hc by lambda இது வந்து nothing but the energy. So அப்படினா I can say 2 into energy divided by time into 1 by c. இதுதான் லெஃப்டா இருக்கு. கரெக்ட்டா? Yes, perfect Akash, perfect Dinagaran, right? Yes. Okay, so இதுல வந்து we got 2e by t into 1 by, I have just replaced this and whatever we have I have written. இப்போ வந்து இது வந்து energy, total energy தான். அப்படினா I'm going to rewrite in terms of energy of photon. அப்படினா n into ep divided by t divided by c. Okay vada? Okay va? I have just replaced the total energy. Okay, total energy I have written it as the number of photons divided by the energy of photon. அப்படினா n na nothing but the number of photons. Capital N கூட you can use it, any representation you can go for it. அப்படினா இதுல வந்து பாக்கும்போது again you guys have to tell me in the energy by time na enna? Energy by time again tell me. Just now only we have discussed in the energy by time na it is nothing but 2 into n by c. Okay, இது வந்து nothing but the power. Okay vada? Okay va? So right now we got 2n by c into p. Next, very good Anzi, very good Agash, very good Darshini. So right now the thing is like I'm going to divide it with a, both the sides. Now can you just tell me what is on the left hand side? In the left hand side la enna irukku? Force by area na enna? Force by area na enna? We are just introducing in the steps. Note panniko, illana after few days you will be get confused. Hey, eppidida in the area. Okay, so we are just dividing both the side with area. Very good Agash, idu vandu pressure. Okay, ipo vandu in the p na power by area na enna? Power by area na it is nothing but intensity. So I can say it is nothing but 2 times n by c. Okay, sorry, 2 times I by c. Okay va? So right now radiation pressure. Okay, இதுதான் வந்து நம்ம radiation pressure. And the radiation of pressure oda expression enna? It is nothing but 2I by c. Okay, it is nothing but coming as 2I by c. I'm going to write again. So in the radiation pressure is nothing but 2 times I by c. So இப்போ வந்து I have considered a reflecting surface. புரிஞ்சுதா? This is for the reflecting surface. This is for the reflecting surface. Right now I'm going to ask you absorbing surface. Okay, அப்படினா இப்போ வந்து இதுதான் வந்து இந்த surface. Okay, இந்த light வந்து it is falling on it. அதுக்கப்புறம் no reflection, absorb ஆச்சு. அப்படினா இதோட momentum வந்து h by lambda. அப்படினா change in momentum கூட it is h by lambda minus 0. Okay, so அப்படினா அந்த கேஸ்ல இந்த radiation pressure வந்து okay, in the radiation pressure வந்து it will become half of it, which is I by c. புரிஞ்சுதாடா? புரிஞ்சிடுச்சுனா give me a fire in the chat box. Okay, simple ஆ தான் இருக்கு. இந்த radiation pressure for a reflecting surface na h by lambda initial momentum minus h by lambda final momentum. புரிஞ்சுதா? Adukapram, what will happen? What will happen? We will find the change in momentum. We will find the force. Adukapram, we are going to mention, we are going to multiply it with C and C, C by C. Adukapram, we are going to divide it with area on both the sides. We will be getting the radiation pressure. Ipa vandu idu absorbing. Okay, absorbing surface na, what is happening? Idoda initial momentum irukum, final momentum vandu 0 da. So adanala in the radiation pressure vandu it will become I by C. Purinjida, everybody got it? Yes or no? Please let me know. Yes, very good. Thank you, thank you, thank you so much. Okay, so ipa vandu we are going for the next one. Next one na, very simple based on this. இதுதா வந்து நம்ம reflecting, இதுதா வந்து நம்ம surface. Okay, இதுல வந்து transmission இருக்கும், which means no absorption, no reflection. So அதனால it is not going to give any force. So no force due to transmission. Next வந்து இந்த surface na reflection, which means it will come and it will go. In the area na it is nothing but absorption. Okay, so இதுல வந்து we know that the total intensity will be coming as due to absorption, due to what to say reflection and also transmission. Okay, idhula vanda IA intensity due to absorption, adukku vanda I will write it as A into I. A is a coefficient of absorption. Okay, A is a very simple coefficient of absorption plus R into I. Okay, R na, what is going to be R? Can you just let me know in the chat box? Can you just let me know in the chat box? Everybody. So, idukku vandu 0 da varapore. So, idu vandu totala we should get I. Okay. So, totala we should get it as I. So, A vandu coefficient of absorption na, R vandu Agash, R vandu coefficient of reflection. Okay. So, A in a coefficient of absorption and R in a coefficient of reflection. Okay, so ipa vandu we got an equation, correct? Okay, we got an equation, and the equation is I is equal to AI plus RI. In the LI equation lume we have I, so we can just cancel it. So we will be getting A plus R, which is equal to 1. Yena in the I vandu cancel actually. Purinjida everybody. So right now we got the equation I is equal to, 1 is equal to A plus R. Okay vada? Okay va? So next one again in the case net radiation pressure da we need to find it. Okay, so idhila vandu what will happen? Due to absorption we know 2IA by C. Due to reflection, okay, due to absorption it will be coming like this. Okay, now we can just give the values 2 into IR by C plus I into A by C. Ipo vandu I'm going to do a very small thing. Idhila irundha I'm going to find A. A ina enna aga pore? It is nothing but R minus 1 minus R. Correct? So we will be keeping A over here. So it will be coming as 1 minus R. Correct ada? Correct ada? No issues, no issues. Just focus, write the notes. Each and everything is very, very important. So idhila vanda A we got it as 1 minus R. Purinjida? A which is equal to 1 minus R. Appadina I'm going to apply here. So idhila vanda I by C na common da. Right now 2R plus idhila irukkiradhu A da. A na enna 1 minus R. Appadina we are going to get I by C into R plus 1 as the value. So, if you know the coefficient of reflection mattumnalum, you can find the radiation pressure. Purinjida? Everybody understood? Please let me know. Very simple da. I will explain one more time. Just focus over here. So, idhula vandu we have a surface, transmission irukum, absorption irukum, also, இது வந்து reflection, இது வந்து absorption. Okay, so right now, as I mentioned, in the total intensity வந்து due to this 3 things, correct? And இதுக்கு வந்து I'm going to tell you, the coefficient வந்து let us take it as T, okay? And இதோட intensity I, okay idha vandu coefficient of transmission idhila vandu this is how it will come and idhila vandu this is right now we got 1 is equal to a plus r plus t so idhila vandu இந்த t vandu 0 ஆக போற so we will be getting 1 is equal to a plus r a vandu coming as 1 minus r புரிஞ்சுதா so இந்த கேஸ்ல வந்து what we need to find net radiation pressure okay net radiation pressure so due to absorption இது வந்து I by C which means IA by C plus IR 2 times correct so now I'm just rewriting I into A by C plus 2 into IR by C so next one the I by C I'm taking out so A plus 2R so once I'm just substituting the A value which means 1 minus R plus 2R which is going to give me the value as I into R plus 1 இதுதா வந்து net radiation pressure in the case la you just need one thing in the coefficient of reflection புரிஞ்சுதா உங்ககிட்ட ஒரு சொல்லணும் என்னோட physics board preparation உங்களால தான் complete ஆச்சு thank you for your great work கடைசி இதுதான் உங்ககிட்ட சொல்லணும் தோணிச்சு thank you ma'am ஓகேடா ஓகே ஓகேவா so இதுதான் வந்து what we need to understand from the radiation pressure okay so இதுக்கப்புறம் can we go for the photoelectric effect okay so now again back to the things we have studied okay recent da in the photoelectric effect ellame we have studied okay so right now beginning from the emission okay so ipo vanda each and every atomilla in the valence electronukku sufficient ana energy kadachena okay sufficient ana energy kadachena what it will do it will just escape adudha vandu what we are saying electron emission so adula vandu we have first one is thermionic emission thermionic emission na again electron oda emission da okay idhula vandu energy provide pandrathu yaru can you give me the answer idhula vandu energy provide pandrathu yaru it is nothing but the heat so by providing heat energy in the electron sufficient energy kadakka pore then it will excite next one is field emission okay field emission na again emission electron oda emission da adukku vandu sufficient energy kadakkanum so idhula vandu in the electric field nala okay we are giving strong electric field appadina in the electron ku energy kadakka pore so what will happen idu vandu excite agum or let's say it will be get escaped next da nama important ana thing that is nothing but our photoelectric effect so in the term photo irundichuna adoda meaning nothing but adukku vandu light I mean it is having some connection with light புரிஞ்சுதா so right now thermionic emission இருக்கு thermionic emission na we are providing heat and the heat energy use பண்ணி இந்த electron வந்து escape ஆகும் field emission na we have to give some a strong electric field adula irundhu it will be getting some energy and it will be get escaped okay புரிஞ்சுதாடா first one thermionic emission using heat energy electron வந்து escape ஆக போற second வந்து strong electric field நால electron க்கு வந்து energy கிடைக்க போற it will be get excited and photoelectric effect na very simple when it is getting sufficient amount of light okay light with proper frequency I'll tell you why we are saying all those okay light with proper frequency again what will happen electron க்கு வந்து sufficient energy கிடைக்க போறே okay electron க்கு வந்து it will be getting the sufficient energy it will escape from the surface okay vada electric it will be escaping from the surface புரிஞ்சுதா yes or no very simple ஆன concept da so right now light வந்து with proper frequency will provide sufficient energy for the electron then it will be ejected okay so now let us focus on the photoelectric effect. Ready, Ada? Everybody is ready? Everybody is ready? And before that, how many of you are writing this, your biology exam? Adukku munadi English exam irukalla. So how many of you are 12th students? Can you let me know? 12th students? Or all are droppers? Please let me know. What class you are studying? Yes. Tell me, which class? 12th or you are a dropper? எனக்கு வந்து I know Akash வந்து 12th. Correcta? I got the information today, right? Okay. So இப்போ வந்து we are straightly going for the photoelectric effect. இந்த photoelectric effect-க்கு புரியதுக்கு முன்னாடி you should know one term. அது வந்து nothing but our work function. Okay, work function da. So in the work function na nothing but phi. Usually we will be represent it as phi. Okay, or let's say phi naught. Okay, yes, fine. So how was your preparations and everything? Everything going well? Good, perfectly going. Let me know. Preparation vandu avlo super ah poitu irukka. So work function is phi naught. So idoda expression da first we should know. Phi naught I will represent it as h mu naught. In the work function nalum it is nothing but a energy. Okay, simple ah sollitena idu vandu oru energy da. And the energy ke we will be more specifically say the minimum energy. Okay, in the work function kuda it is a energy. ஆனால் அந்த எனர்ஜி வந்து மினிமம் தான். ஓகே, மினிமம் எனர்ஜி. எதுக்கு இந்த மினிமம் எனர்ஜி? ஃபார் த எலக்ட்ரான் டு எஸ்கேப். ஓகே, ஃபார் தி எலக்ட்ரான்ஸ் டு எஸ்கேப். ஸோ அப்படின்னா ஃபர்ஸ்ட் வந்து we are going to define work function. work functionனா very simple டா. it is very simple. இப்போ வந்து we have an electron. Okay, so அது வந்து we are considering a metal surface. அதில் வந்து we have valence electrons. இந்த electronsக்கு minimum energy கிடைக்கணும். கரெக்டா? இப்போ வந்து 3 days we are not even had anything. Okay, in the 3 days we didn't had anything. So இப்போ வந்து wake up பண்றதுக்கு, okay, to wake up we need some energy, right? இந்த minimum ஆவது we need a glass of water. கரெக்டா? டு சர்வை. ஸோ அந்த மாதிரி இந்த எலக்ட்ரான்ஸுக்கு மினிமம் எனர்ஜி தேவையா இருக்கு டு எஸ்கேப். ஓகே, அந்த எனர்ஜி தான் இந்த ஒர்க் ஃபங்க்ஷன். ஸோ ஐ கேன் எக்ஸ்பிளைன். இந்த ஒர்க் ஃபங்க்ஷன் வந்து த மினிமம் எனர்ஜி required for an electron to escape from the surface. இதுதான் வந்து work function. இதுல வந்து as I mentioned இந்த mathematical expression வந்து h mu naught our Planck's constant. கரெக்டா? இது வந்து nothing but our Planck's constant. அப்படினா இந்த phi naught is completely depending upon this mu naught. இப்போ வந்து I wanted to tell you இந்த mu naught னா என்ன? இந்த mu naught னா என்ன? Okay, mu naught we will call it as threshold frequency. Okay, threshold frequency. So இப்போ வந்து ஒரு student she or he understood in the work function என்னன்னு. அப்படினா you guys have to tell me how we can define in the mu naught எப்படி we can define. work function na minimum energy required. ஆனா இந்த minimum energy இந்த energy term depend பண்றது இந்த threshold frequency தான். அப்படினா இந்த threshold frequency வந்து can you give me the answer in the chat box? It is nothing but the minimum frequency required same for an electron to escape from its surface. அதுதான் வந்து very good Hiran, right? Yes. So அது வந்து nothing but the minimum frequency required for an electron to escape from the ground. Okay, Akash. Okay, fine. Okay, yes, Vimala. Okay, so we got the minimum frequency. Again, we know it is nothing but C by lambda. Appadina, in the threshold frequency, we can say it as C by lambda naught. Appadina, I'm going to rewrite this equation. H into C by lambda naught. Purinjidada, everybody? Purinjidada? So, now the work function that we have studied. Work function na the minimum in the electron minimum energy da in the work function. Okay, adoda mathematical expression vanda in the Planck's constant into the threshold frequency. Planck constant na it is a of course it is a constant value. Appadina in the work function depend pandrathu it is only with the work only with the threshold frequency. Appadina in the threshold frequency I'm again rewriting it as C by lambda. Okay, so now you will be getting work function as well as in the lambda naught. Purinjida? Everybody got it? Yes or no? Give me a fire in the chat box, everybody, if you understood. Everybody? Yes, perfect. So, appadina, right now you have, you have defined, everyone has defined what is mu naught. Now, can you tell me what is lambda naught? What is lambda naught? I will again write it as, I will tell in the lambda naught, I will call it as threshold wavelength. Now, tell me how you will be defining this. In the lambda naught, how you will define? Tell me. Lambda naught threshold wavelength. How you will explain? Idhula vanda work function paathena adu directly proportional to threshold frequency, inversely proportional to the threshold wavelength. Appadina instead of minimum I should say the maximum wavelength which for an electron required to, yes, very good, Akash, be careful. Okay, so right now it is nothing but the maximum wavelength required. Purinjida? Now straightly we are going for the experiment. Okay, so adikaga we have a glass tube. Okay, evacuated glass tube we have. Okay, so this is the glass tube, and now you have the two plates over here. Okay, then we have a commutator to fix the to change the polarity. Okay, to change the very good to change the polarity of the our this thing. Okay, so idhula vanta you can just go for in the, okay, so we can just go for like this. This will be connected like this. This will be connected like this. And here we will be having a battery as well. So we can just go for a battery like this. So in the commutator we will be use it for the changing the polarity. So idhula what will happen in the light it will fall on this plate. Okay, light will fall on the plate. So when I said the photoelectric effect, on the time I have clearly mentioned to you. So adula in the electron sufficient energy kadacha mattumda and the emission, or let's say in the electron escape panna mudiyum. Correcta? So light with proper frequency or light with sufficient frequency na sufficient energy kadakkirum. So if this light, okay, in the light which is coming to the plate, right, and the time and the energy correcta purinjuko, and the energy more than this work function na. Okay, so in the light photons irukum, correcta? Okay, listen carefully. In the light photons irukum. So in the photon it will interact with the electron, correcta? So anga in the photon energy in the electron will absorb. So இப்போ வந்து it got energy. Energy kadachena what will do? Yes, it will escape. Listen carefully. Now what is happening? In the photons vanda it is falling on the surface. Okay? So அதோட energy வந்து அந்த energy of photon இது வந்து energy of individual photon. If that is greater than work function na mu naught, which means h mu naught supposed to be greater than h mu. What is h mu, guys? Can you just tell me what is h mu? And the photon oda energy, the light வந்து இந்த பிளேட்ல வந்து fall பண்ணல, so அதோட energy தான் இந்த h mu. Okay வா? அந்த energy of photon, if it is greater than that of the okay, so இது வந்து greater ஆச்சுனா, okay, greater ஆச்சுனா what will happen? And the emission will happen. Very good. Energy of photon. Okay வா? So each photonக்கு வந்து h mu energy இருக்கு. அப்படினா I can again இந்த sideல h இருக்கு, இந்த sideல h இருக்கு. So to be specific, okay, to be specific I can say இப்போ வந்து the frequency of photon is greater than the work, or let's say the threshold frequency na the electron emission will happen. Okay, electron emission will happen. இல்லனா என்ன ஆக போற? As I mentioned, இப்போ வந்து you are not even getting water. So I mean once if water da we are getting, அது sufficient அல்ல. We need 1 glass of water. புரிஞ்சுதா? So இந்த 1 glass of water கடச்சேனா we will wake up. So அந்த மாதிரி இந்த எலக்ட்ரானுக்கு sufficient-ஆ energy கடச்சேனா it will wake up, it will escape. புரிஞ்சுதா? I hope you guys got it. Yes. Okay, very good, fine. அந்த knowledge போதோட அதுதான் வந்து basic. Okay, so right now we got it. இந்த energy கடச்சிருக்கு. Okay, so இதோட energy, இந்த லைட்டோட energy வந்து அந்த photonோட energy வந்து greater than that of work function na what will happen? It will escape. அப்படினா I can say இதிலிருந்து இந்த electrons வந்து it will be moved towards the other side. Okay, அங்க வந்து positive தான், attraction இருக்கும், correct? So it will travel from this plate to this plate. When it will happen? When energy of the photon is greater than the energy threshold, or let's say the work function na idoda energy vanda this electron emission will happen. Appadina let us say as I mentioned to wake up you need only 1 glass of water. Okay, to wake up you need only 1 glass of water. Ana vandu you are going to get 2 glass of water. Then what we will do? We will wake up and we will walk. Correcta? Purinjida? So right now if I am giving an energy which is more than எனக்கு வந்து sufficient I mean wake பண்றதுக்கு இந்த electron eject பண்றதுக்கு only I need h mu naught. இப்போ வந்து what is happening? எனக்கு வந்து some extra energy இருக்கு. கரெக்ட்டா? எனக்கு வந்து எக்ஸ்ட்ரா எனர்ஜி இருக்கு. h mu தான் டோட்டல் எனர்ஜி. அதுல வந்து h mu not யூஸ் ஆச்சு. அது வந்து eject I mean அந்த சர்ஃபேஸ்ல இருந்து எஸ்கேப் பண்றதுக்கு தேவையான எனர்ஜி. The rest of the energy in the h mu ல okay I need only 2 electron volt as energy. Okay, எனக்கு வந்து 2 electron volt தான் எனர்ஜி required இருக்கு. அப்படினா I am getting 5. So இந்த 3 electron volt will be used for the kinetic energy, which means the electron has to travel from one plate to another plate. Correct? இந்த பிளேட்ல இருந்து இந்த பிளேட்டுக்கு மூவ் ஆகணும்ல, அதுக்கு வந்து kinetic energy இருக்கணும்ல. So அதனால the energy of the photon is splitted as used for work function. அதுக்கப்புறம் what is left அது வந்து kinetic energy convert ஆக போகுது. So அப்படினா I can say in the energy of photon will be equal to phi naught plus kinetic energy. அப்படினா kinetic energy க்கு கூட I can write an expression. Kinetic energy வந்து it is nothing but total energy minus work function, which means EP minus phi naught. Note பண்ணிக்கோ. Okay, everyone has to whatever be the things. Okay, what are the things I'm writing in the board, அது வந்து ப்ராப்பரா நோட்ல நோட் பண்ணிக்கோ. Okay வாடா? ரெடியா? I hope you guys got all the equations. Yes or no? Yes or no? Tell me in the chat box, everybody. Tell me in the chat box, everybody. Understood? Yes or no? Yes. So, இப்போ வந்து we got the kinetic energy which is equal to EP minus phi naught. Okay va? I can also rewrite hc by lambda minus hc by lambda naught, which means hc if I'm taking out 1 by lambda minus 1 by lambda naught. This is also another expression. In the each and every expression வந்து note பண்ணிக்கோ. ஏனா questions வரும்போது we will be get confused. Okay, which equation in the equation in the lambda இருக்கிற equation I didn't even study it. Then how I'll be doing it? So அதனால தான் try to write the possible different types of equations. Okay, so இதுல வந்து இந்த kinetic energy ஓட expression வந்து I can write it like this. Okay, so now this part is sorted. Next வந்து இதுதான் வந்து ஐன்ஸ்டீனோட formula. Next வந்து it is nothing but stopping potential. So இப்போ வந்து I am just changing the polarity. Polarity na இந்த surface இல்ல இந்த plate இருக்கல இந்த light வந்து fall பண்ற அந்த plate அது வந்து positive ஆச்சு. பாசிட்டிவ் ஆச்சுனா இந்த எலக்ட்ரானுக்கு அட்ராக்ஷன் தான் கரெக்ட்டா இந்த பிளேட்ல பாசிட்டிவ் பொட்டன்ஷியல் தான் ரைட் நவ ஓகே even if the light comes it should have that much energy to escape from this கரெக்ட்டா okay so now let us say the energy வந்து அவ்ளோ ஹை தான் ஓகே இந்த எலக்ட்ரான் வந்து எஸ்கேப் ஆச்சு ஆனாலும் what will happen when it comes to the other side, which means இது வந்து positive தான் right now, இது வந்து negative தான் okay light will fall on this one okay இந்த electron will be electron வந்து so strong attraction இருக்கும் ஏனா positive potential electronக்கு வந்து அவ்ளோ attraction இருக்கும் அப்படினா even if we are giving a large energy also it will try to come. Okay, it will try to come. ஆனா வந்து at some point ல இங்க இருந்து நெகட்டிவ் தான் எலக்ட்ரான் கூட நெகட்டிவ் தான் so there will be a repulsion and this electrons will stop. இப்போ வந்து we know இந்த charges ஓட flow okay அதுதான் what we are calling it as current கரெக்ட்டா the flow of charges தான் nothing but current okay வா இந்த flow of charges. So in the case இங்க இருக்கிறது electrons தான் and it is due to the light okay இந்த flow வந்து இந்த electrons ஓட flow வந்து it is due to light அதனால I will call this current as photo current புரிஞ்சுதா very simple இப்போ வந்து இந்த electronsக்கு sufficient energy கிடைச்சிருக்கு and it will travel to the other side and in the electrons ஓட flow நால we are going to get the current அதுதான் வந்து what we are calling photo current okay அதுதான் nothing but photo current புரிஞ்சுதா first point இப்போ வந்து polarity change ஆச்சுல அதனால இந்த electron even if it is try to come also in the negative potential நால it cannot travel much so at some point it will stop which means in the flow of charges வந்து stop ஆச்சு கரெக்ட்டா in the flow of charges வந்து stop ஆச்சு so now I can define in the stopping potential வந்து the potential at which okay the potential at which the current, the photo current becoming zero and the specific potential in the stopping potential. புரிஞ்சுதா? So as I mentioned, when we are changing the polarity na, what is happening? This negative potential vanda, it will stop. It will try to stop the electron. At some point it will come to rest, which means anga flow of charges illa. Flow of charges illana அந்த பாயிண்ட்ல current வந்து zero ஆச்சு. அந்த zero ஆகுற, அந்த current zero ஆகுற corresponding potential தான் stopping potential. I hope you guys understood. If you understood, give me a fire in the chat box. Quickly you can give me a fire. Okay, so simple ஆன concept தான். So இதுல வந்து stopping potential தான் we are going to explain. So இதுல வந்து simple we can say in the electrons வந்து traveling from the one potential to the another potential. இங்க வந்து polarity change ஆச்சுனா at some point in the flow வந்து stop ஆகும், current flow வந்து stop ஆக போகுது. And the corresponding potential the stopping potential. Okay, so right now we have studied a lot of things. First one in the work function. Work function ennada? Work function enna? It is nothing but the minimum energy required for the electron to escape from the surface of the metal. When I am repeating this, you also try the same. Whenever you are getting stuck, which means you are not getting the concept. புரிஞ்சுதா? So note பண்ணிக்கோ, whenever you are just repeating the thing, if you can't complete na adula வந்து concept clarity la ஏதோ problem இருக்கு. புரிஞ்சுதா? Next வந்து threshold frequency தான். Threshold frequency என்ன? The minimum energy required for the electron to escape. Third வந்து the threshold wavelength தான். அது nothing but maximum wavelength which is required for the electron to escape. Fourth வந்து we have studied the photocurrent. Photocurrent na enna? Due to the light, electrons will be ejected from the metal surface and it will move. Due to this there will be a current developed and on the current da in the photocurrent. Next one the important fifth point, if the electron is getting more than the work function, electron is getting an energy more than the work function na, adula vandu in the electron it will use the work function to escape from the surface. The rest of the energy will be for the kinetic energy to travel from the point. Correct? Third one vandu, sixth one vandu, when we are changing the polarity na, in the plate la vandu positive ah irukum, sorry negative ah irukum, in the plate la vandu positive, in the plate la vandu negative. Okay, அப்படினா இந்த positive plate la electrons க்கு வந்து attraction இருக்கும். So we need more energy for the electron to escape. Okay, இப்போ வந்து அந்த அளவுக்கு எனர்ஜி கொடுத்துட்டனாலும் what will happen, இந்த சைடுல இருந்து நெகட்டிவ் பொட்டன்ஷியல் வருது, அதனால it cannot travel. At some point la இந்த flow வந்து இந்த electron வந்து it will come to rest. Okay, so we can say அந்த மொமெண்ட்ல corresponding ஆன potential தான் stopping potential. Now I am going to rewrite this equation. Okay, rewrite this equation. இப்போ வந்து I have mentioned the kinetic energy. In the kinetic energy will be converted as the potential energy. And the corresponding potential தெரியும், and இதில் இருக்கிற charge வந்து potential na Q into V. Correcta? இதில் வந்து Q na electron, so E. And in the stopping potential da, so Vs. அப்படினா இந்த equation இல்லையா, energy of photon which is equal to the work function plus kinetic energy, அது வந்து I'm going to rewrite h mu naught plus E into Vs. So இப்போ வந்து energy of photon which is used for work function plus the potential energy. Now I got another equation. In the equation kuda important da. Okay, so right now the things which we have studied is about the basic experiment, about the basic experiment. If yes, Einstein photoelectric equation da. So இப்போ வந்து what we have mentioned, இதுல வந்து இந்த photo current இருக்கு, அந்த photo current stop or let's say அது வந்து zero ஆகுற moment தான், momentல இருக்கிற அந்த potential தான் stopping potential. Now I made a new relation as well. So those who are joined new, please don't forget to like the video. Okay va? Okay va? Ipo vandu we need to we need to study some of the relations. Okay, we need to make some dependent, independent things. Okay va? So right now we have studied all those things. Idhula vandu we know energy of photon na hm. Okay va? So appadina I can say that in the energy of photon is depending only on frequency. Am I right or wrong? Okay, in the energy of photon depends in the frequency. Appadina I can say that when frequency increases, energy of photon also increases. Important concept. Okay, in the frequency reduce achuna, what will happen to the energy? In the frequency reduce achuna, what will happen to the energy of photon? Can you give me an answer for that? Everybody, energy of photon ki enna agapore in the frequency reduce achuna? Can you give me the answer? Yes, h vandu Planck's constant da. Yes, all the answers, everything is already written. Sati, right? Satish, okay, Satish, yes. Energy vandu decrease agapore. So when mu decreases na, in the energy of photon kuda decrease agapore. So energy is completely depending upon this. Now we also written in the energy which is equal to hc by lambda. H vandu Planck's constant value. C vandu 3 into 10 to the power 8. Again constant value. Appadina I can say energy vandu proportional to 1 by lambda. Appadina in the lambda increase achuna, tell me what will happen to energy. Quicka you can give me the answer, everybody. Quicka you can give me the answer. Quicka you can give me the answer. Very good. In the energy vandu decrease agapore. Yena inverse relation. So in the lambda vandu reduce achuna, energy vandu increase agapore. So idha vandu in the energy frequency dependence. Next vandu I am going to tell you about the intensity. Okay, next vandu intensity da. So intensity la we should know few things. In the intensity na it is actually proportional to the number of photons. Okay, which means the brightness is more na, number of photons vandu more. Purinjida? In the intensity increase na, in the bright light, the brightness increase achuna, number of photons vandu increase achu. Okay, intensity intensity is independent of this energy. This is another important statement. Okay, intensity increases or decreases, it is not going to affect the energy. Dark light agatum, in the bright light agatum, adila vandu energy ku change illa. Energy is completely depending upon frequency. Which means, let me say intensity vandu 5 units. Okay, idhula vandu intensity 3 units. Idhula vandu frequency vandu let us say 10 to the power 10 hertz. Idhula vandu 10 to the power 20 hertz. Okay, idhula vandu let me say idu vandu A, idu vandu B. Which one will be having more energy? Idu da vandu intensity, idu vandu frequency. Appadina first case la A or B, which one will be having the more energy? Which photon will be having the more energy? Can you give me the answer? Yes, very good, Satish. Intensity is independent of frequency. So now tell me which one, A or B? Yes. In the B is having the more energy. B is having the more energy. Yena adoda frequency increase da. Okay, even if it is having 10 units or 15 units as intensity, increases. Aanalum energy vandu it is not going to depend upon intensity. Adanala I can say that in the intensity vandu it is not depending upon energy, or more specific I can say it is not depending upon the frequency. I can only say in the intensity vandu proportional to the number of photons. So bright light na more number of photons irukku. Correct? And I can also say in the intensity reduce aachuna dark light na number of photons vande reduce aga pore. Now here is the turn. Okay, here is the turn. We know one photon can interact only with one electron. Okay va? One photon can interact with one electron. So ipo vandu first light la 5 photons da irundiruchina 5 electrons will escape. 10 photons irundiruchina 10 electrons will escape, which means 10 electrons will travel. Appadina I can say that when intensity increases, what will happen? Number of photons increases. Important guys, number of photons increases, then number of electrons ejected increases, and hence we can say in the photo current will also increase. Idu vandu important. Okay, idula vandu intensity increase ஆச்சுனா number of photons வந்து increase ஆக போற. ஒவ்வொரு photonக்கும் I mean it can only interact with one electron. So அதனால 5 photons இருந்தா 5 electrons, 10 photons இருந்தா 10 electrons. அப்படினா 10 electronsனால, which means when number of photons increases, number of electrons ejected கூட increase ஆக போற. Now more number of electron flow na we can say and the current due to the electron flow and the current kuda increase aga pore. So adinala if I am plotting intensity versus the photo current, okay, intensity versus the photo current, it is going to be a linear relation. Okay, number of photons increases, corresponding number of electrons will also increase. புரிஞ்சுதாடா? Very 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 important relation da. Okay, okay, now another question. Okay, yes, very good. Now another question, you should give me an answer. Okay, simple ana question da. If I am increasing the intensity, how or what will happen to the stopping potential? Intensity increase aachuna stopping potential ku enna aga pore? Can you give me the answer? Quick, can you give me the answer? Everybody, quickly you can give me the answer. So in the photon la yes, very good, it won't change. Yeah, we know that in the photon oda I mean energy vanda utilized for few things. Correct? It is utilized for few things. Adula vanda first thing na work function. அதுக்கப்புறம் இருக்கிறது தான் இந்த கைனடிக் எனர்ஜி. when polarity changes na அந்த total energy தான் இந்த stopping potential depend பண்றது. இது வந்து remains same. It is not going to change. Even if you are taking the intensity to next, I mean if you are giving that intensity also, in the stopping potential வந்து change ஆகாது. புரிஞ்சுதா? ஆனா if I am plotting this, okay, if I am plotting this, I can go for இதுதான் வந்து நம்ம intensity. Okay, இது வந்து நம்ம what is a stopping potential. So potential, I'm just mentioning it as potential. So intensity increase ஆச்சுனா as I mentioned the photo current increase ஆக போற. ஆனாலும் இந்த what is a sorry, what I have mentioned is wrong. Okay, so இப்போ வந்து the stopping potential won't change. Ana intensity increase aachuna what will happen? In the photo current vande increase aga pore. Okay, so when intensity increases, current in the saturation of current vande same aga, I mean increase aga pore. Ana stopping potential vande change agadu. Yena adu vande depending upon the work function as well as the total energy of electron, photon. So adanal it is not going to be affected. Ana vanda saturation current, which means let us say in the photons will interact with the electron, it will move. Again another photon will come, it will move. Correct? So in the madri, in the process will come, and once all the electrons will come to the other side, I will call it as saturation current, which means in the electron illa. Correct? So we can say that in the saturation, it has reached the saturation, adu vanda depending upon intensity. Okay vada? In the graph vanda, in all these cases, in the graph vanda important da. Okay, are you guys ready for the next one? Are you guys ready for the next one? Yes or no? Give me a fire if you understood all the two graphs. If you understood the graph, please let me know. Give me a fire in the chat box. Quicka, you can give me a fire if you understood. Quicka, you can give me. Yes, perfect. So let us go for another one. So next one, in the, we know that if we are increasing or decreasing frequency nalum, in the photo current vanda change agadu. Yena adukku vanda intensity depend பண்ணிட்டு இருக்கு. Okay, next வந்து I'm going to plot photo current here. Okay, inga வந்து potential. Okay va? So ipo வந்து I'm going to change the frequency. Okay, change the frequency. அப்படினா what will happen? So definitely வந்து இந்த current வந்து change ஆகாது. Correcta? So the graph will be like this. Okay, so in the current, saturation current வந்து change ஆகாது. Okay, saturation current வந்து change ஆகாது. ஆனா வந்து we know that in the potential, in the stopping potential வந்து change ஆக போறேன். Okay, so இதுதான் வந்து நம்ம frequency mu2, mu1 and mu3 தான் the largest. Okay, and இதுதான் வந்து corresponding potential. So we can see that and the potential கூட increase ஆச்சு. So frequency is completely depending upon, in the potential வந்து completely depending upon the frequency. அதுல வந்து photo current will be remains the same. Okay, next வந்து I wanted to plot the stopping potential versus, okay, stopping potential versus the 1 by lambda on a graph. அப்படினா அந்த graph எப்படி இருக்கும்? Can you just give me an idea? In the stopping potential versus 1 by lambda that I'm going to plot. அப்படினா அந்த graph, which type of graph you will be getting? Which type of graph you will be getting? How you will be getting? We know h mu, which is equal to h mu naught plus EVS. ஏனா kinetic energy வந்து I wanted to replace, ஏனா வந்து I want VS. Okay, so இதுல வந்து I can write hc by lambda, which is equal to hc by lambda naught plus EVS. இப்போ வந்து I'm taking this over here. Okay, and also let me do one thing. I'm dividing it with E. Okay, or multiply with E, both the sides. Appadina what will happen? We will be getting hc E lambda, which is equal to hc by E lambda naught plus Vs. Appadina in the side la we are going to replace it. So this is how we will be getting. So idudha vanda equation we are getting. So idhula vandu paakumbodhu you can just do one thing. In the hc vandu we can take it out. hc by E vandu you can take it out. So you'll be getting 1 by lambda and 1 by lambda naught, which is equal to Vs. So right now I'm focusing on this one. Okay, so idu vandu if I'm just checking with y is equal to mx plus c. So ipo vandu if you're just checking on this value, h vandu constant da, c vandu constant da, E வந்து constant தான், lambda not for a specific electron வந்து same தான். கரெக்டா? அப்படினா இந்த வேல்யூ வந்து constant ஆக போறேன். கரெக்டாடா? இந்த வேல்யூ வந்து constant ஆக போறேன். So if I am plotting this, I will be getting a linear graph. புரிஞ்சுதா? அதோட ஸ்லோப் வந்து செக் பண்ணும்போது mx, இதுதான் வந்து mx. x na 1 by lambda. We are plotting vs versus 1 by lambda. அப்படினா by comparing this, in the slope வந்து it is nothing but hc by e. அது வந்து constant da. So we will be getting a graph like this. In the graph வந்து important da. Whenever we are plotting the stopping potential versus 1 by lambda. புரிஞ்சுதா? 1 by lambda na first வந்து you should make a relation. Okay, ஏனா vs வந்து we are going to plot in y. X வந்து we are going to plot in the 1 by lambda வந்து we are going to plot in the x-axis. அப்படினா we will be getting this relation. இதில வந்து when we are comparing it with the linear equation y is equal to mx plus e na, y will be coming as vs, x will be coming as 1 by lambda, mx we can see that it is nothing but hc by lambda. So அதனால இந்த m வந்து hc by e தான். இது வந்து constant value. In the slope you can expect a question, you can expect. So அதுதான் வந்து we have to study. புரிஞ்சுதாடா everybody? Understood na? Give me quick வந்து you have to give me a fire in the chat box. Everybody quickly you can give me the fire. Quick you can give me a fire. Yes. Hi Tanya, right? If I'm pronouncing it wrong, please correct me, okay, va? Okay, yes. So next topic we can go for the next topic, right? Adukapram we can do some questions. Adukapram we can go for the next chapter. Okay, vada? Okay, va? Yes or no? Yes. Okay, so right now we are going to discuss the failure of wave theory. Simple concept, failure of wave theory. Idhula vandu first thing is, in the photoelectric effect illaya, in the photoelectric effect vandu oru instantaneous process da. Okay, இது வந்து instantaneous process, which means it is happening like around 10 to the power minus 9 second or 10 to the power minus 10 second. அவ்வளோதான் இந்த time required. So அதுதான் வந்து we are mentioning wave theory. I mean, in the photoelectric effect ல அந்த electron eject பண்றதுக்கு தேவையான time வந்து இவ்வளோதான், which means it is an instantaneous process. அப்படினா okay, அது வந்து instantaneous na, according to wave theory ல ரொம்ப ஸ்ட்ரேஞ்சான திங் தான். இதில் வந்து கண்டினியூஸாக இந்த எனர்ஜி வந்து டிஸ்ட்ரிபியூட் ஆச்சு. இட் வில் டேக் சம் டைம். ஓகே, அந்த டைம் லேக் இந்த ப்ராசஸில் இல்லை. அதனால we have to conclude that இந்த லைட்டுக்கு வந்து பார்ட்டிக்கிள் நேச்சர் கூட இருக்கு. நெக்ஸ்ட் வந்து இன்டென்சிட்டி இன்க்ரீஸ் ஆச்சுன்னா இந்த எனர்ஜி இன்க்ரீஸ் ஆகணும் அக்கார்டிங் டு வேவ் தியரி. ஓகே, இன்டென்சிட்டி இன்க்ரீஸ் ஆச்சுன்னா இந்த எனர்ஜி கூட இன்க்ரீஸ் ஆகணும். ஆனால் that is not happening. We did the experiment. அந்த எக்ஸ்பெரிமெண்ட்டில் அந்த மாதிரி எதுவுமே it is not happening. அதனால again it is again a particle nature. Okay, right now we will come to it. Relax. Okay. So right now we also mentioned in the frequency part. Okay, in the frequency we know in the stopping potential வந்து it is depending upon frequency. ஆனா according to wave theory அந்த மாதிரி ஒரு டிபெண்டன்ஸே இல்லை. ஸோ இதுதான் வந்து failure of the wave theory. புரிஞ்சுதா? இதுதான் வந்து failure of wave theory. ஸோ next வந்து what we are going to discuss is இந்த மேட்டருக்கு, ஓகே, இந்த மேட்டருக்கு வந்து wave property இருக்கு. லைட்டுக்கு வந்து we have mentioned wave property இருக்கு. இப்போ வந்து we have proved that இதுக்கு வந்து particle nature கூட இருக்கு. நெக்ஸ்ட் வந்து இந்த மேட்டர், ஓகே, அதுக்கு வந்து what is the, அதுக்கு வந்து particle nature இருக்கு, we know it. ஓகே, ஆனால் அதுக்கு மேட்டர், ஓகே, அதுக்கு வந்து wave properties கூட இருக்கு. அதுதான் வந்து whatever we are calling it as the matter waves. ஓகே, அதுக்கு வந்து we will call it as matter waves. Or we will call it as de Broglie waves. okay, which means idhula vandu each and every particle, okay, usually vandu we can observe this for the very small particles like electron, proton, idhula tha what we can see this. புரிஞ்சுதா? So when we are talking about in the matter waves, or let's say in the de Broglie waves na adula vandu we can see this in the very small particle, okay, in the small particles la mattum da we can see the matter waves. புரிஞ்சுதா? So அப்படினா in the matter waves வந்து we can see only in the smaller particles, அதோட wavelength வந்து it is going to be very less. ஆனா அந்த wavelength, okay, அந்த wavelength we are defining it as lambda, which is equal to h by p. Look at this equation. Lambda na அது வந்து wave property, அது define பண்றது வந்து ஒரு particle property தான், கரெக்டா? ரைட் ஹேண்ட் சைடு பார்க்கும்போது அதில் இருக்கிறது momentum, அது வந்து particle property. So அப்படினா இந்த lambda வந்து we can say it as it is nothing but h by p. H by p na we can also write it as h by mv, correcta? We can replace p as mv. Next வந்து we can also say in the mv na in terms of kinetic energy it will be coming as 2mk. We can also write replacing the kinetic energy as root of 2 into m into qv. இப்போ வந்து in case of electron na இந்த lambda வந்து for electron na இந்த charge வந்து e ஆக போற, so you will be getting this one. Okay, so now if you are just putting the values, ஏனா electronக்கு வந்து h, m, e எல்லாமே we know it, அதனால அந்த value calculate பண்ணும்போது you will be getting 12.27 root 2v Armstrong. Okay, so இதுதான் வந்து இந்த wavelength. For an uncharged particle you can again replace energy with 3 by 2 kBT. That will also give you another equation. So இதுதான் வந்து we need to discuss in this chapter. Majorana எல்லா topics-உமே we have covered. இதுல வந்து you should know the equations, some of the equations which is very important. Okay, correcta? Okay, so இதுல வந்து first we have started with the photons. Okay, quick we can have a revision. Okay, adukapram we can go for the solved questions. Okay, so ipo vandu as I mentioned idhula vandu what we have a photon. So and the photons oda properties da we have studied. Adil irukira ovvaru point ume important da. Okay, ovvaru point ume important da. Whatever I have wrote in the board adu vandu you have to understand, you have to study. ஏனா அது basic da, அதுதா வந்து base. Okay, other related new problems you can expect. அதனால தான் I'm telling you in the beginning ல அந்த photons ஓட property ல whatever I have mentioned கரெக்ட்டா நோட் பண்ணிக்கோ. இந்த கிளாஸ்க்கு அப்புறம் இந்த notes வந்து comment box ல you will be getting it. அதில இருந்து if you want you can just copy it. அதில each and every point வந்து அவ்ளோ important. Next வந்து we have discussed about the radiation pressure, correct? We have discussed about the radiation. Before that we have discussed about the intensity. Okay, and the intensity equation da number of photons into the power in the equation la p வந்து power divided by area. And the intensity equation we have found for the point source as well as for the linear source, correct? இப்போ வந்து we have found the radiation pressure as well. இப்போ வந்து reflecting surface na அதோட expression வந்து 2I by C. Okay, radiation pressure for a reflecting surface வந்து 2I by C. Next வந்து absorbing na, okay, absorbing na அதோட expression வந்து I by C. Next we have mentioned இப்போ வந்து I mean it is a absorbing reflecting surface. Okay, partial da இருக்கு. அப்படினா அதோட expression வந்து we already found it I by C into R plus 1. R na அந்த reflection coefficient da. இதுல வந்து if it is given in terms of A na இங்க வந்து you can just give the expression for A also. புரிஞ்சுதா? So அதுதான் வந்து இந்த radiation pressure. Also in radiation pressure you can just note it down one more thing. Okay, right now for an absorbing surface in the radiation pressure வந்து we know I by I by C. Okay, I by C. Correct, Ada? Correct. So in the pressure, na, it is nothing but F by A, which is equal to I by C. Appadina, F will be coming as intensity by speed of light into area. Correct? So force vanda, we can just find it as I by C into A. Now, the thing is like, let us say I have a cone over here. Okay, I have a cone over here. Correct? So, the number of photons which is passing through it is like this. Appadina, ma'am, idhula vandu cone oda area illame we need to find it illaya. So, adu vandu difficult agapporella. Find the, just take the shadow. So, in the cone oda shadow na enna, adu vandu simple ah vandu oru triangle da. Correct? And the madri, if I am going for a sphere, okay, and the sphere badala, you can just go for the circle. Yena, you just imagine, inga vandu oru cone irukku. Idhula vandu photons will be passing. Okay, so on the same number of photons da, adoda shadow irundum we can say the number of photons, or let's say number of light rays vandu, it will be same as passing through from cone as well as adoda shadow. So adanala in the 3D irundiduchuna, you can make it to 2D, and I mean we can just rewrite this equation. F will be equal to I by C into area of projection. Idu kuda you can study it. So even if it is a complicated structure also, you can find the area and you can do it. Yes, Vadi, it is alive. Okay, so this is what basically we need it in terms of radiation pressure. In the equation kuda important, very important. Adukapram we have done with the experiment. In the photoelectric experiment da we have did it, and adu kuda very important. Okay, so next one, let us do one thing. Let us go for a quick or 10 minutes break. We can go for it. Adukapram we can go for the problem solving. Ready ada? Ready ya? Quick we can go for a 10 minutes break. Okay va? So idhula vandu proper I have written all the notes, everything. So you can just after the session you can just check it out. You will be get it in the description box. Okay? Okay va? So right now we have 5. Okay. So let us meet at 5:45. 5. Okay. So you have to be come at this time. Let us continue with the problem solving. Okay. Fine. Yes, so we are going to solve the questions right now. So idhula vandu first question you can see here. Okay va? Okay, hi Akash. Yes, yes, yes. I hope everybody is taking, drinking water and walking in between. Illana, idu vandu few hours illaya. So adanal continuous you're not supposed to sit for a long time and also drink water in between. Okay. Wow, very good, very good. Went for cycling. Perfect, perfect, perfect. So அந்த மாதிரி ஏதாச்சும் activities we have to do இல்லனா அது வந்து difficult ஆ இருக்கும். Okay வா? So let us do this question. Ready ya? Ready na? Give me a fire everybody. Ready na? Give me a fire. Let us do this question. Simple ana question. I will give you hint also. Then you can give me the answer. Okay. So the energy that should be added to an electron to reduce its de Broglie wavelength from 10 to the power minus 10 meter to 0.5 into 10 to the power minus 10. So idhula vandu what they have asked is the energy we need to make, or let's say we need to reduce the lambda to lambda by 2. Correct? So adukku thevayana energy da we need to find. So அப்படினா இதுல வந்து energy இருக்கணும், lambda இருக்கணும். Correct? அந்த மாதிரி which equation we have? We can go for lambda which is equal to root of 2me. So இப்போ வந்து you can go for lambda 1 by lambda 2. So அதில் வந்து பார்க்கும்போது you can see lambda will be proportional to 1 by root e. So it will be coming as root e2 divided by root e1. So இதில் வந்து lambda 1 and lambda 2 you have. So now you can just do the, you can just make the relation. E2 and E1 relation. Simple ana question da. So idha vandu equation what we are needed for this question. Adukapram you should take the ratio. While you are taking the ratio, in the lambda vandu inversely proportional to E da. 2 vandu constant, M vandu constant da in the case la. Now you can just give the values and you can go for it. Check again. Accuracy is more important than speed. Correct? Check it and give me the answer quick. Very good. So idhula vandu how we will be doing it? Lambda 1 na 10 to the power minus 10 divided by 0.5 into 10 to the power minus 10, which will be coming as root of e2 divided by root of e1. So idhula vandu this will be get cancelled and in the side la we are going to get 2. Now I am squaring both the sides. So appadina I will be getting e2 by e1. So 4e1 will be equal to e2. So idudha vandu the solution. Simple ana question illaya. So idhula vandu lambda 1 by lambda 2 we have to find. Adula vandu first you have to go for lambda na, adu will be inversely proportional to 1 by root e. Now you will be making the relation. Adukapram both the sides vandu you can square it. Okay va? So in the answer vandu option A da. Okay. Not thrice anyway, 4 times da. Okay. So next vandu another question. A photosensitive metallic surface has work function, okay, in the phi naught vandu h mu naught da. If the photon of energy 2h mu naught, in the photon oda energy vandu 2h mu naught da falls on the surface, the electron come out with a maximum velocity which is equal to 4 into 10 to the power meter per second. When the photon energy is increased to 2, okay, now the thing is like we are increasing the photon energy to 5h mu naught. Then what is going to be V dash? This is the question. You can just go for the equation. The energy of the photon, which is equal to work function plus kinetic energy. Kinetic energy na half mv square. Okay va? So right now substitute for the first case EP na 2h mu naught, which is equal to h mu naught plus half into m into 4 into 10 to the power 6. So like this way you can go for the second equation as well. Check it, you will get it. Very simple question da. So inga equation irukku. So first one the energy kaga you can just write the equation. So adala irundha you will be getting, you can just go for the kinetic energy and you are getting the kinetic energy. Second equation la you can go for K2 as kinetic energy, which will be equal to the total energy minus the work function. Okay, so let us go for it. So idhula vandu what we will be doing. So in the question la first case na 2h mu naught minus h mu da in the kinetic energy. Adu vandu we will be getting h mu naught by subtracting them. So adila vandu second equation na adila 5h mu naught minus h mu naught, which will be giving you K2, which is nothing but 4h mu naught. So இப்போ வந்து பாக்கும்போது h mu naught na அதுக்கு answer K1. So K2 na it is nothing but 4 times K1. So 4 into K1 na half into m into V1 square. So adoda value you can just go for it. So m into V1 square na 4 into 10 to the power whole square. So you can just do this and you will be getting the answer for, because in the side la vandu half into m into v dash square, correct ah? So idhula vandu half m will be get cancel. So appadina what we are going to get in the v dash square will be equal to 4 into 10 to the power 6 the whole square. Okay, yes, very good. So we are getting the answer as option D. Okay, now let us go for the next question. Are you guys ready? Yes. In a photoelectric experiment, the wavelength of incident radiation is reduced. Okay, wavelength வந்து reduce ஆச்சு. Wavelength வந்து reduce ஆச்சு. அப்படினா what will happen to the stopping potential? We know that in the stopping potential வந்து it is depending upon frequency. So அப்படினா இந்த wavelength வந்து reduce ஆகும்போது what will happen to the energy? அது வந்து you can connect and you can come to the conclusion. Okay, you just need to understand the concept how stopping potential is connected with the lambda. So the energy will be equal to the work function plus in the stopping potential da. So appadina I can say in the energy we can just write it as hc by lambda. இது வந்து work function, அது வந்து அந்த மெட்டலுக்கு வந்து சேம் ஆக போறே. So 5 naught plus EVS. So இப்போ வந்து இந்த value reduce ஆச்சுனா what will happen to this value? அதுதான் வந்து question. இதுல வந்து 5 naught na அது வந்து constant value தான். So now can you give me the answer? Simple ஆன question, simple ஆன options தான். Concept வந்து right now we got it. Very good, very good, very good. So இதுல வந்து answer வந்து option B தான். Okay. So now let us go for the next question. Yes, very good, very good. So next question. When a certain metallic surface is illuminated with a monochromatic light of wavelength lambda, the stopping potential for photoelectric current is 3V0. When the same surface is illuminated with a light of wavelength 2 lambda, the stopping potential is V0. The threshold wavelength for the surface for photoelectric effect is. So, let us just read the first sentence. When a certain metallic surface is illuminated with a monochromatic light of wavelength lambda, which means adoda energy vandu hc by lambda. The stopping potential is coming as, appadina, in the work function plus 3 into EV0. Correcta? Yena E into Vs, E into 3V0. When the same surface is illuminated with, appadina, hc by 2 lambda, the stopping potential becomes, so phi minus E into VO. The threshold wavelength for the surface for photoelectric effect is. So we need it in terms of lambda. Okay. Okay, va? So in the question lab, we need it in terms of lambda. So right now you can just check this question. In the part you can just resubstitute. Okay. So phi da verum, so you can just either remove electron volt or otherwise you can just remove the hc by lambda. So if you are just rewriting, hc by 2 lambda phi minus, sorry, why we are writing it is going to be plus. Okay. So, hc by lambda minus phi will be coming as EV0. Appadina, inga we can just resubstitute this. So, how you will be getting hc by lambda, which is equal to phi minus 3 into hc by 2 lambda minus phi. Now we can expand phi minus 3hc by 2 lambda minus 3 phi. So what we will be getting, we can just take this hc lambda terms over here. So hc by lambda plus 3hc by 2 lambda, which will be coming as 2 phi. Okay. So I'm just going to multiply and divide by 2. So what you will be getting, 5hc divided by 2. Somewhere we made a mistake. What is the mistake we have done? hc by lambda, this is the two equations we have. Now we found what is EV0. Adu vante hc by 2 lambda minus phi. We are substituting it. Correcta? Okay. So on the substitution we made some mistake. So hc by lambda, which is equal to phi minus phi plus 3 into hc by 2 lambda minus phi. Yeah, yes, perfect. I have made the same mistake. Yes, Jenny, I'm good. How about you? Okay. So now you can expand 5 plus 3hc by 2 lambda, again minus phi. Okay, minus 3 phi. Okay. We have to multiply inside. Now you can just rearrange and you will be getting the solution. Yes. Done. Did you get the answer? Everybody check it again. I made a mistake, da. Agash, thank you. So now you can just go for the answer. Quicka, you can give me the answer, guys. Just take the HC terms over here. Yes, Jenny, do the question. We don't have much time. Okay. So now you can do this way. HC 2H by 2 lambda. I wanted to make the denominator same. 3HC by 2 lambda, which will be coming as 2 phi. So now if you are just checking on, you will be getting HC by 2 lambda the 2 phi. Okay. So right now we need the wavelength. So HC divided by, okay, HC divided by, will it come as 4, okay, which is coming as the lambda. Now you can just replace 5 from this, you will be getting the answer. Okay, so 4 lambda da idoda answer varudhu, correct. Okay, so very simple ana question. First one, you have to write the equation for both the cases. Adukapram you can just replace EV naught, adukapram you can just rearrange. Okay, so we are going for the next question. According to Einstein's photoelectric equation, the graph of kinetic energy of the photoelectron emitted from the metal versus, which means kinetic energy and frequency, gives a straight line. Adoda slope enna? Adoda slope enna? Kinetic energy versus frequency da, adoda slope da we need it. So right now we know that in the energy which is equal to phi plus kinetic energy. Appadina h mu minus h mu naught, which is coming as kinetic energy. Okay, so appadina now you can just tell me, by looking at this equation, you can tell me what is going to be the graph. Kinetic energy oda equation we have written. So now you can give me the answer in the chat box. So idla we can just say that it is same for all metals. Yena adoda value h da, and independent of the intensity of radiation. Okay, and the slope in the Planck's constant da varapore. So adinala it will be same, and it is not in the material depend panduna adokku we know that idla y is equal to mx plus c format da. Adila we can just see that in the x part da in the h mu naught. So adinala and the value kuda constant agapore. So the answer is going to be option C. Next one, the work function of metal A and B. Okay, work function of metal A and B are in the ratio, which means phi A divided by phi B 1 by 2. Or otherwise I can replace phi A as 2 times phi B. Okay. And if the light of frequency f and 2f are incident on the surface of A and B respectively, the ratio of maximum kinetic energy of photoelectron emitted is. So we need the kinetic energy ratio. Again the same equation we will use it here. K is equal to HF minus phi. Okay. So idhila first you can go for K1. Again you can go for K2. So idhila paakumbodhu you know K1 adoda frequency enna? Adoda frequency enna? A yoda frequency F da, minus idoda work function. So let me just write it as phi A. Okay, KB na, it is nothing but H into 2F. Yena adoda frequency 2F da, minus phi B. Okay, phi B. Now phi B you know. Okay, phi B we can just write it, or phi A we can just write in terms of phi B. So HF minus 2 times phi B. Okay. So now you have to take the ratio. Can you go for the ratio? Can you find the ratio? Can you find the ratio? Yes, do it. Yes, 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 Kavin. Perfect. You can do it. Okay, so what will happen? Right now, we can just go for the ratio Ka by Kb. So, we will be getting HF minus 25b divided by 2HF minus 5b. Okay, so what will happen? We won't be getting the ratio, right? Work function of a metal A and B in the ratio 1:2. If the light of frequency F and 2F are incident on the metal surface A and B respectively, the ratio of the maximum kinetic energy. So maximum kinetic energy, we can just write it as the energy minus work function. So energy the first case la HF, correct illaya? Yes, da. So I think there is some confusion in the question. Okay, so either it has to be instead of the first case F must be 2F, otherwise we won't get the answer. So in the question la correction irukku. So maybe it will be given as 2:1. Then I hope it will be sorted. Okay, so 2:1 na 2:1 na what will happen in the 5A which is equal to 25B. Okay, if you are changing the question only, we will be getting the right answer. Otherwise, we won't get it. Okay, and the question la correction irukku. So now you can say in the Ka HF minus 5A na 25B. I'm just writing it as 25. KB na H into 2F minus 5. Correct. Okay, in the previous I made a mistake, I hope so. Correct. HF minus 5A will be 25B. Okay. 5A by 5 will be 2 by 1. So 5A will be 25. Okay, somewhere some correction is there. Okay. So let us just go for the next question. I think that will be better. Okay, fine. 1:2 that is given. So maybe the value is given in a different order. That's it. So now we can just go for the another question. When UV light of wavelength 100 nanometer is incident upon silver plate. Okay. So wavelength 100 nanometer. A potential of 7.7. Okay, potential of 7.7 volt is required to stop the electrons from reaching the collector plate. How much potential will be required to stop the photoelectrons when the light of wavelength 200 nanometer is incident upon it? So, idukkaga again we will be using the same equation H mu which is equal to H mu naught plus this potential EVS. This is the equation we need to use. So right now you can just go for it. You have to convert all the units in terms of electron volt. So you can see that here when I am writing for the potential. So that is H mu minus H mu naught divided by E in the stopping potential. Correct? So in the first case, stopping potential was 7.7 da, and also in the H mu. Okay, so adu you can just write in terms of our in terms of lambda. Yena question la in terms of lambda it is given. So H by E 1 by lambda minus 1 by lambda naught. Okay, so idhula work function. Okay. Okay, so right now you can just substitute the values. So the first case 7.7 electron volt will be coming as our in the H mu is coming, right? How we can just write it? Okay. So let us just do one thing. We can just convert into electron volt. Okay, that will give you the answer. Okay, you can just convert in terms of electron volt. I think that will give you the answer. Just need to convert. So electron, again you can just keep it here. Okay, so ipo vandu hc by lambda minus work function, which is equal to EVS. So E into 7.7 you can just do. Yes, perfect. Yes. Very good. So now in the equation hc by lambda kaga I am just going to write 12.24. Okay. Electron volt nanometer divided by first lirundha 100 nanometer da minus 5 under 7.7 E. Okay, so in the E will be get cancelled. Now from this you can just find the phi value. Adikapparam you can just go for the same equation, you can go for it hc by lambda minus in the phi value whatever you are getting, that you can substitute and you can find the second potential. So adoda answer it will be coming as idhula only one thing, sorry, 12.24 it is going to be 12.40, sorry, okay, 12.1240 when we are converting into electron volt nanometer na, it will be coming like this. So you can just directly substitute and you can find it. Then there is no much confusion in the calculation. You will be getting 1.5 volt. Now let us go for the another question. A parallel beam of monochromatic light of wavelength 620 nanometer is incident on a surface of 2 meter square. So area it is given as 2 meter square. The number of photons striking the mirror per second is 1 into 10 to the power 19. The intensity of the light. So we know that in the intensity of light oda equation the total energy divided by area into time. So in the case n is given, area is given, and in the wavelength is given, so that you can just find the energy as well. Adikappuram idu n by t it is given. The number of photons striking per second in the 1 into 10 to the power 19 value. Adikappuram energy you can find it as hc by lambda. So which will be coming as 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by in the lambda 620 into 10 to the power minus 9. So you can just substitute area 2 and also you can just rest of the old values we got it. Now you can go for I. N by T 10 to the power 19, energy 6.6 into, so idu you can just write it as 6.2 around, and this will be coming as 11, okay, minus 11. So appadina we need an approximate value, so you can just cancel it out. So adukapram you can just equate with the powers. So on the top 10 to the power minus 34 irukku, 10 to the power 8 irukku, and down again minus 11 irukku. So, this approximately 10 to the power 9 it will come. Okay. So, in the energy approximate you will be getting 10 to the power. Okay. So, this is what you are going to get. Adikapram you can just multiply it with 10 to the power 19 into this energy by area. Okay. So, already N by T is given. So, you can just substitute and you can find it. Okay, yes, the answer is going to be option A. Now let us go for the another question. An electron and a photon possess the same de Broglie wavelength. Okay, electron and proton is providing the same de Broglie wavelength. EB and EP respectively are the energies of electron and proton. V and C are their respective velocity. Appadina in the EB by EP ratio da we need it. This is the question. In the question la very simple. First of all, you know that in the electron oda kinetic energy vandu half mv square da. Correct? And same as for the photon oda energy na it is nothing but, okay, photon oda energy na it is nothing but hc by lambda. Now you can just do one thing. You can also rewrite this term, because yena in the lambda we know it, right? Okay, in the lambda na it is nothing but 1 divided by not the lambda vandu it will be equal to kinetic energy. No, what was the lambda equation we have studied? Yes, hc. Okay, hc divided by root of 2 into m into k. Correct? So in the k da in the ee. So adanale I'm just going to square this side. Okay, so h square c square divided by 2 into m into ee. Now you can just rewrite, okay, you can just rewrite ee from this equation. Okay, va? Now you can try. Right now we got EE in terms of lambda. Adikapram we can just take the ratio. Energy of electron we got it half mv square. So adu we need to replace in terms of lambda. So adukagata we have done lambda which is equal to hc divided by root of 2me. Okay, I hope you are getting it. So idhula vandu what is happening? Lambda square divided by h square c square which is equal to 1 by 2me. In the hc by lambda na we know ep. So adanala I can say 1 by ep square vandu 1 by 2me. Now you will be getting ep square which is equal to 2 into m into e. Okay, so right now, you can just replace m. So m na ennaga pora ep square divided by 2ee will be coming as m. Now you can substitute that over there. Okay, so now you will be getting this energy in terms of in the ep. Adikapra you can just take the ratio, sorted. Can you try it? Simple ana question da. First one we got yes, very good. So idhula vanda first we got the energy of the electron, adu vanda half mv square da. Adikapram we know the energy equation of photon also, adu vanda hc by lambda da. Adikapram we know lambda of an electron, adu vanda we have applied and we got the equation and we substituted for m. Adikapram we will be getting the ratio as v by 2c. Yes. Next question, when the energy of incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from a metal surface is increased from 0.5 electron volt to 0.8 volt, the work function of the metal. Again in the question, you have to write the equation. So first case, incident radiation, I'm just writing it as E. Okay. So, on the time work function plus kinetic energy vandu 0.5 electron volt da. Second case la varumbodhu in the energy increased by 20%. So I can just write it as it will be coming as 1.2 into E. ஏனா வந்து we know, let us say இந்த energy வந்து 100 okay, so 20% increase ஆச்சுனா how we will say 120, correct? So that quantity will become 120. So அதனால இந்த energy E na அதோட 20% increase ஆச்சுனா it will be coming as 1.2 E. அதுக்கப்புறம் work function and this becomes 0.8 electron volt. So idilirundhu you can just find the work function. So in the energy equation you can just go for 1.2 into 5 plus 0.5 electron volt, okay, which will be which will be equal to 5 plus 0.8 electron volt. So by sorting this you will be getting what is 5. So either you can just remove 5, okay, ஏனா இதில் வந்து first you will be getting the energy equation by removing 5. அதுக்கப்புறம் you can just substitute the value of energy also. Otherwise you can just go for this method. Any method will work, no worries. Okay, simple ஆன concept தான். So இதில் வந்து first we wrote the two equation. அதுக்கப்புறம் we are giving the E value in the equation. Equation 1 தான் இது, equation 2. So now we are giving 1 in 2. அதுதான் what I have done here. So இது வந்து you can make it expand. அதுக்கப்புறம் you will be getting the answer for 5. இல்லனா you can just go for removing this 5 from this equation or multiply the whole equation with 1.2. So again this E will be removed. Again you will be getting the 5 value. Okay? Yes. The answer will be 1.5. Oh sorry, 1 electron volt that it is coming. So what is happening here? 1.25 plus 0.5 into 1.2 electron volt, which is equal to 5 plus 0.8 electron volt. So appadina in the 5 will be coming this side. So 0.25 will be coming as 0.8 electron volt minus we can go for 1.2 will be coming as 1.2. We can just make it as 1.2 divided by this will be coming as 0.6 electron volt. Okay, so what you will be getting, 0.25 will be coming as 0.2 electron volt. So by taking this you will be getting 1 electron volt. I hope you made some mistake or Agash. Okay, Akash. Okay, so idudha vanda process. So idhula vanda you will be getting 0.2 divided by 0.2, which will be coming as 1, that is whatever 1 electron volt the answer. I hope you made some mistake in the calculation. So correct ana calculation inga irukada. Okay, so next one, if the wavelength of the incident light falling on a photosensitive material decreases, lambda decreases. I think we have done this question, right? Lambda decreases na in the stopping potential வந்து increase. Positive ஆயிதா, so minus 1 it will come, so it will come as 0.2. அதுக்கப்புறம் இந்த term வந்து it will be coming over here, so we will be getting 0.6. I think simple calculation error da. Okay, you do it again after the class, you are going to get the answer, no worries. Okay, so இப்போ வந்து we are going for the next chapter. அது வந்து nothing but our atom. So when we are talking about atom, the first thing is nothing but we have to introduce the Thomson's model. அதுதான் வந்து first in the NCERT la வந்து first we are starting with that. Okay, so Thomson's model onwards da இந்த syllabus la இருக்கு. Okay வா? So Thomson's model la very simple da. அதுல வந்து plum pudding model da. We will call it as plum pudding model. So as per his concept, in the atomilla positive and negative charges வந்து it will be just how the in the plums வந்து இந்த pudding இல்ல plums எப்படி இருக்கும் அதுபோல அந்த same type ல இந்த electrons and positive charges வந்து distribute ஆருக்கு. அதுதான் வந்து first he has proposed, and he also found the ratio E by M ratio also he has found. Okay, so E by M ratio also he has found. It will be coming around like 1.7 into 10 to the power 11. Okay, so இதுதா வந்து Thomson's atomic model la we need to discuss. அதுக்கப்புறம் what happened? Yes, we have the Rutherford's alpha scattering experiment. in the scattering experiment we could find a lot of things. So idhula vanda first thing na majority ana in the alpha particles vanda it is actually without deviation it has reached on the target, which means in the atothila majority ana space vanda empty da. Okay, so in the Rutherford alpha scattering experiment first observation vanda in the alpha particles vanda without deflection it has reached on the target. Adanala we can say that in the atothila majority vanda free space da. Purinjudha, it will be coming as free space. Next vanda we should know very few particles vanda deflected more than 90 degree, which means deflect ஆகணும்னா அங்க வந்து again ஒரு positive charge இருக்கணும், கரெக்ட்டா? அந்த positive charge வந்து concentrated to a point. Okay, it is not having much space, ஆனாலும் it has occupied on the in the atom, and due to that only in the alpha particles வந்து scatter ஆச்சு. So next one is there is a positive charge. Okay, there is a positive charge which is concentrated inside the atom. So இதுதான் வந்து மேஜரா இந்த Rutherford alpha scattering experiment we could find. And ஆனா வந்து இந்த Rutherford model we could see that so he has proposed like this, in the electrons வந்து it is rotating around the what is a nucleus. In the nucleus வந்து இதுல சென்டர்ல வந்து பாசிட்டிவா ஓகே ஒரு பாசிட்டிவான ஒரு குவாண்டிட்டி வந்து it is there. ஆனா வந்து he couldn't explain limitation da. Okay, limitation da we have to focus. In the limitation na he couldn't explain about the stability. Okay, also he couldn't explain nothing about the spectral lines. Okay, so it is nothing but zero total charge vandu. Adanal he could explain neutrality also, and he could explain idhula vandu nucleus irukku, adula vandu adu vandu small portion da irukku, adanal da in the deflection happened, and he couldn't explain about the stability of the atom. Yena vandu in the electrons இந்த மாதிரி rotate பண்ணனும்னா அதுக்கு வந்து as per the energy conservation idhula vandu it will just rotate and it will eventually come to the it will fall on the nucleus. ஆனா அப்படி நடக்கல, கரெக்ட்டா? So அதனால he couldn't explain about the stability. In the electrons continuous in the nucleus if it is rotating na correcta sonna we can say adoda stability, or let's say it has to come and fall on the nucleus. Ana appadi edum it is not happened. Okay, so now we can say stability also in the in the electrons vandu when they are changing their state and the time la in the spectral lines irukum. Okay, and he couldn't explain about that as well. So idudha vandu first thing. Next we should know the distance of closest approach. Okay, distance of closest approach. So idhula vantha simple ana concept da. Let us say we have a lighter electron. Okay, we have a lighter nuclei, or let's say we have a very light charged particle. Okay, and right now we have a nucleus over here. Now this is coming with a velocity v, correcta? So now let us say in the nucleus vandu positive da, in the charged particle also vandu positive da. So at some point when it is coming to the idoda charge vandu z1e, idoda charge vandu z2e. Appadina just understand in the particle vandu coming with a velocity v. Okay va, coming with a velocity v. In the nucleus vandu it is stay as rest. Okay va, purinjuda? In the particle is coming like this, in the nucleus vandu at rest. Appadina listen carefully. Idhila we know that according to momentum or energy conservation, in the total energy vandu conserved ah irukanum, correcta? So appadina in the beginning stage la what is happening, there is only kinetic energy, adudha vandu half into mv square. Okay, adikapram when it is coming to close to this at some distance r, okay, at some distance r it will come to rest. which means idoda kinetic energy வந்து completely it is changed to the potential energy. Now we know in the potential energy na 1 by 4 pi epsilon naught q1 q2, correct? So I'm just putting it as e square, q1 q2 na idhula vandu z1e and z2e. So now I can just write z1 z2 divided by e square divided by and the distance vandu r. Now the question is, what is the closest distance of approach? In the charged particle nala, how much distance it can travel and it can come closer to the nucleus. So idhula vandu now you can just go for a rearrangement, half into m into v square 4 pi epsilon naught divided by z1 z2 e square, which will be coming as 1 by r. Now you can just write r will be equal to, on the topmost point la 4 pi epsilon naught irukku, m sorry okay, r now we can just write z1 z2 e square 2 divided by m v square 4 pi epsilon naught. So idudha vandu namma distance of closest approach, z1 z2 e square divided by 2 pi epsilon naught m v square. Purinjudada? Purinjuda? So in the equation also, of course, we should have a basic idea, right? Adanala daga we have to go for some basic ideas. In the Bohr oda, in the Rutherford limitation and everything, it is asked. So idudha vandu namma distance of closest approach. Idhula vandu in the two venona we can just cancel it out. So you will be getting z1 z2 e square divided by 2 into pi epsilon naught m v square. But I will suggest you can just better go for this equation. Yena straight vandu you can apply for the value of 1 by 4 pi epsilon naught, and that will help you. Okay, so idudha vandu we need to study in the closest distance of approach. Now I'm going to give you a question. You can just do this question. So right now the thing is like, we have an alpha particle. Adoda kinetic energy is given as 10 mega electron volt, and it is heading towards a point, what is a nucleus. Okay, adoda atomic number vandu 50 da. Okay, now you guys have to find the closest distance of approach. Okay, so idhula vandu alpha particle irukku, adoda kinetic energy is given 10 mega electron volt. Adukapram and the nucleus oda atomic number kuda it is given 50. Appadina in the distance of closest approach vandu what is going to be that? Again the same, if you even if you are not remembering the equation also, simpla vandu we know the total energy initial which is equal to final. Appadina half into m v square which is equal to z1 z2 e square divided by 4 pi epsilon naught r. So ipo vandu alpha particle da, so adoda z vandu it is coming as 2. So now you can just substitute the values. So kinetic energy straight it is given 10 mega electron volt, z1 na 2, z2 na 50. Can you do it? So now you can just go for idu vandu 10 into 10 to the power 6, which is equal to what we will be getting, 2 into 50 into e square into 9 into 10 to the power 9 divided by r will give you the answer. Okay, what is value? Which value da? Epsilon naught you don't need to. That is what I said. You can just go for 1 by 4 pi epsilon naught. Okay. Better you go for 1 by 4 pi epsilon naught. Yena vandu we know the exact value. Adu vandu it will simplify our problem. So by doing this, you will be getting the R naught value something like 1.44 into 10 to the power minus 14 meter will come as the answer. Very good, very good, very good. So now we have discussed about the closest distance, everything. Now let us go for the yes, Bohr's model. Okay, in Bohr's model, the first postulate is, we know that this electrons, okay, we have these electrons, and in the electrons it is moving in a circular path. அதுக்கு தேவையான centripetal force வந்து இந்த electrostatic force தான் அதுதான் centripetal force act பண்றது, which means if any particle should go in a circular path னா அதுக்கு வந்து centripetal force இருக்கணும், கரெக்டா? So இந்த கேஸ்ல வந்து according to Bohr's model அந்த centripetal force mv square by r வந்து k into z into e, அதுதான் வந்து நம்ம nucleus ஓட charge, into e divided by r square. So இதுதான் வந்து first postulate. Okay, an electron if it is revolving around the nucleus na அதுக்கு வந்து centripetal force இருக்கணும். அந்த centripetal force will be provided by the electrostatic force between the nucleus and the electron. Second வந்து regarding the stability. Stability, when we are talking about the stability na, in the electrons vanda, it will travel in a stable stationary orbit. Okay, it will always travel in a stationary fixed orbit. Okay, it will always travel in a stationary and fixed orbits. And on the orbits order, angular momentum, which means L, which is equal to mvr, will be equal to the integral multiple of nh by 2 pi. This is what is the second postulate. Okay, first postulate it is traveling in a circular path, adinala idukku what is the centripetal force is there, which is provided by the force between electron and the nucleus. Second வந்து இதெல்லாமே fixed orbitல travel பண்ணிட்டு இருக்கு. அந்த fixed orbitக்கு angular momentum இருக்கு, அதுதான் வந்து nh by 2 pi. And the third one is, if an electron, okay, jumping from one to another one, it will exert, or let's say it will absorb or emit a photon, and it will go to the, so I can just go for EF minus EI, which means இப்போ வந்து இந்த electron வந்து it is jumping from one orbit to another one. Okay, அப்படினா what will happen? One orbit to another orbit na, it has to release h mu, which means it has to release a photon. And the photon energy release panida, it will be coming back to the lowest energy level. இப்போ வந்து இதுக்கு வந்து highest orbit க்கு travel பண்ணனும்னா it should absorb a photon and it has to move. புரிஞ்சுதாடா? No worries, Mohana, right? So இதில வந்து as I mentioned, start with the 9th grade topics. அதுதான் உங்களுக்கு தேவையா இருக்கு. அதுக்கப்புறம் maths you have to focus. By the time the regular classes will start, you can go for it. Okay, so இப்போ வந்து these are the 3 postulates of what is our Bohr's model. Now the thing is like, we have to find some of the expressions. Let us say for the radius. Okay, first வந்து we are going for the radius. அதுக்காக equation, we will be using the first postulate. 1 by 4 pi epsilon naught ze square divided by r square, which is equal to mv square by r. So in the r வந்து cancel ஆக போறே. So what we will be getting, 1 by 4 pi epsilon naught ze square divided by mv square will be coming as r. Let it be there. இதுதான் வந்து first equation we are writing for the r. Also we know that second postulate la it is mentioned nh by 2 pi. Correcta? mvr, which is equal to nh by 2 pi. அப்படினா I can also write nh by 2 pi into mv da இந்த r ஓட expression. புரிஞ்சுதா? Now you can just equate this two. Okay, in the left hand side in both the equations the same da. Appadina I will be getting 1 by 4 pi epsilon naught ze square divided by mv square will be coming as nh by 2 pi mv. In the equation you can find the v value. So in the v will be get cancelled. Adikapram you can go for 1 by 4 pi epsilon naught ze square inga irukku divided by mv. So adula I'm just taking v outside. So idudha in the side la irukku z square divided by m. Idhila irundha nh will be coming down, 2 pi m will be coming on the top, which is giving you v. So idu cancel aga pore. So now after this in the v ze square divided by 2 epsilon naught into nh. Okay, so in the velocity I could say it is proportional to z by n. So in the equation direct by heart pannanuma ma'am? No, it is not required. Okay, yena in the equations you know how to do it. Idu quick you can do it. First the centripetal force we are equating with mv square by r. Adilirundu you are going to find what is r. Adikapram you are using the second postulate. First and second postulate you are going to find r. Equate panna pora. Adikapram you will be getting the expression for v. So on the v oda expression ze square divided by 2 epsilon naught nh. And இது பார்க்கும்போது இந்த e square 2 epsilon naught h constant da. அதனால தான் I have written v is proportional to z by n. So I'm writing over here v is proportional to z by n. If you are not studying anything, at least study the relation, how velocity is depending upon the z and n is very important. Okay, so இப்போ you got the v value, correct? You got the v value. Let me just put this as the third equation. Now what I'm going to do, this 3 in 2, which will be giving me the expression for r connecting z and n. Let us see. So idhula the third equation we are going to substitute. So r will be coming as nh by 2 pi m into v na ze square 2 epsilon naught nh. So by doing this, in the 2 will be get cancelled. Adikapram n square h square epsilon naught divided by what we have after that z e square m. So n square h square epsilon naught divided by m into z square pi will also come. Okay, so idhila paakumbodhu you can see h square epsilon naught e square m and pi constant da. Adanala I could say in the r proportional to n square by z. In the relation kuda important da. As I mentioned, if you guys are not studying or if you are just completely ignoring this nalum, in the relation you have to study. In the v is proportional to z by n, as well as in the r is proportional to r square by z also important. Okay vada? So in the relations important da. Okay, so next we need to get the expression for kinetic energy. Kinetic energy na half mv square da. So idhula paakumbodhu v oda expression we know ze square half into m into ze square divided by what is the rest coming 2 pi, sorry not 2 pi, 2 epsilon naught, right? 2 epsilon naught nh the whole square. So this is the kinetic energy expression. So when you are doing this, what you will be getting, half into m into z square e to the power 4 divided by 4 epsilon naught nh, which means m into z square e to the power 4 8 pi, sorry, epsilon naught nh. Kinetic energy will be equal to, okay, we know, let me just write it as, okay, in the kinetic energy minus 2 times, or sorry, potential energy da high aga pore. So 2 times kinetic energy with minus. Okay, potential energy vanda always it is going to be negative. Yena it is bound with the nucleus, correct? So adanala we should keep a negative sign. So now you can say 2 times kinetic energy vanda equal to potential energy. Adanala it will be coming as minus into m into z square e raised to 4 divided by 4 epsilon naught nh. And there is a relation between U and E, or let's say kinetic energy and total energy is having a very simple relation. Kinetic energy or minus K will be the total energy. Appadina in the total energy vanda minus mz square e to the power 4 divided by 8 epsilon naught nh. Okay, so idudha vanda expression for kinetic energy, expression for potential energy, also the expression for the total energy. So you guys should know only this equation. Minus E will be equal to kinetic energy minus in the potential energy vanda E will be equal to, we can go for U by 2, or let's say 2 times E vanda equal to U, and you can go for minus 2 times K will be equal to, or let's say 2 times K will be equal to minus U. In the expressions mattum bodum, the rest of the equations you can simply find it out. Purinjadada everybody? Yes or no? So ipo vanda we need to find an expression for the energy. Okay, we need to go for the energy equation. So we know that when an electron is moving from second energy to the first one, appadina it has to remove, or let's say it has to emit a photon. Okay, so it will be, so usually vanda in the electrons, okay, both வந்து definitely derivation important da. Ana in the NEET la in the using this derivation you can go for it da. Yena you cannot study all this equation. That is the basic idea. Okay, in the chapter la irukra equations வந்து by heart பண்றது it is a what is stupid thing da. In the equations eppadi varudhu adu mattum da you have to check it. Okay, if you are just spending 1 minute nalum in the relations ellame complete ah unnala you can just do it. As I mentioned, first la irundha in the R V adukapram kinetic energy ivlo da you need it, correct? In the R kaga first you will be taking the first 2 postulates of Bohr. Okay, adilirundhu you will be getting R. So in the left hand side of both the equation vandu R da, adanale equate and find V. Once you get the V na, adu vandu you have to substitute in the second postulate la we have found R, right? Adala vandu in the V you can substitute. You are going to get the relation for R. Adukapram in the energy thing da, energy la what you will be doing? You will be just substitute the value for V. Kinetic energy na half mv square da. Adukapram kinetic energy oda inverse, or let's say kinetic energy with a negative sign, adu da vandu total energy. Adukapram you can just go for 2 times total energy da in the potential energy. Done. Okay, that's it. Now we have, as I mentioned, in the energy, when it is traveling from a higher energy level to the lower energy level na, it has to release some energy, adu da vandu h mu. Correct? So h mu da and the energy. So now what I'm going to do? In the h mu na, I can just write it as hc by lambda, and idu vandu hc by lambda 2 minus hc by lambda 1. Okay, so idu da vandu basic we are going to do it. Okay, sorry. So electron oda expression, right? Okay, so right now the thing is like, whenever we are finding the energy equation okay, whenever we are finding the energy equation, okay, whenever we are finding the energy equation, we will be getting this one, right? Yes, correct. Did we make any mistake? Yes, we made mistake. N square h square, n square h square, n square h square, n square h square, everywhere in the n square h square irukku. ஏனா இந்த எனர்ஜி வந்து 4 epsilon naught square will also be there. Okay, not here. Okay, perfect. So, இப்போ வந்து இந்த equationல பார்க்கும்போது minus இங்க இருக்கும் m then e to the power 4 in the 8 epsilon naught square h square இதெல்லாமே when we are doing it we will be getting minus 13.6. Okay, then we can just write z square by n square. So the way we have written the velocity same as here also you can make the relation in the total energy வந்து proportional to z square by n square. If you are feeling like it is difficult now, we know in the velocity வந்து z by n தானா, z by n தான். So energy வந்து we know it is half mv square. அப்படினா இந்த velocity வந்து it is proportional to z by n னா இந்த energy வந்து proportional to v square தான். So we are going to get v square na z by n the whole square. அப்படினா இந்த energy வந்து coming as z square divided by n square. So இப்போ வந்து if you are doing this you will be getting that value as minus 13.6. So that is what we are going to substitute here, minus 13.6. Okay, divided by இதில வந்து z square இருக்கு, n square na I will be going for n2 square minus again the same value. So this will be coming as 13.6 z square divided by n1 square. Okay, so in the case la n1 n2 na it will be coming as 2, idhula vanda 1 da varapore. Purinjudada? So e2 minus e1 which is equal to h mu. So idhula vanda e we have found minus 13.6 z square by n square. அப்படினா இதில வந்து minus 13.6 z square divided by in the case la n வந்து 2 தான். So 2 square minus of 13.6 into z square divided by 1 square. In the case la இது தான் வந்து we will be getting. Now the thing is like in both the cases la we can just find 1 by lambda. புரிஞ்சுதா? We are going for 1 by lambda. So அதுக்காக I'm going to do one thing. 1 by lambda na இந்த hz வந்து அந்த சைடுல இருக்கணும். So minus 13 or let's say I'm just taking 13.6. Okay, 13.6 z square divided by hc. What else we have? So இதில வந்து 1 by n I square minus 1 by nf square irukku. So idoda value again 13.6 into z square divided by hc na. Okay, z square whatever be the atomic number we can just substitute. In the value வந்து it will be coming as r the Rydberg constant. Adoda value வந்து 1.1 into 10 to the power 7 da. So r z square divided by 1 by ni square minus 1 by nf square. புரிஞ்சுதா? So r into z square 1 by ni square minus 1 by nf square. இதில வந்து Rydberg constant ஓட value வந்து 1.1 into 10 to the power 7. Okay வாடா? Everybody understood? So இதில வந்து we will be putting the values and we can just find the lambda value for different cases. Okay, now let us do one thing. Quick வந்து again we can just go for a 10 minutes break. அதுக்கப்புறம் we can go for the what to say our spectral lines, the emission and absorption spectrum. We can go for it. Let's just take a quick break. Okay va? Okay, so let us meet at 7 time. Hello everybody. So yes, again we are back to atom. So in this we have mentioned about the energy. So right now we know that this energy is coming as minus 13.6 Z square by N square electron volt. So this is what our energy. Okay, and now we have found this lambda, 1 by lambda will be coming as R into Z square into 1 by Ni square minus Nf square. Correct? So these are the important equations which you should. Yes, Agash. Yes. Fine. Mano, we are already doing everything in the channel. Okay, you can just check or check the videos which have done. So don't worry, all the videos, everything is there. Okay. So now this is what the equation. Next is nothing but we are going to discuss about the absorption spectrum. Absorption spectrum. So actually this we can discuss for hydrogen or hydrogen-like ions. Okay, wow. So right now the thing is like in this absorption spectrum, we can see that what is absorption spectrum first. So when an electron is absorbing some energy, which means the energy equivalent to one photon, which means h mu, and it will be going to the higher level, which means idudha vandu namma n is equal to 1. Okay, this is nothing but n is equal to 2. Idudha vandu n is equal to 3. Ipa vandu in the electron which is in the ground state, which is jumping towards the second energy level. So we know that for a hydrogen atom, Z will be 1. So this will be coming as minus 13.6 divided by N square. So when N is equal to 1, this energy is going to be minus 13.6 electron volt. When N is becoming 2, this is coming as minus 3.4 electron volt. And again coming to the next energy levels na, and the gap vandu 0 agapore. So right now the thing is like we know minus 13.6 to minus 3.4 na around like 10.2 electron volt. Okay, 10.2 electron volt energy it has to get to go for the next energy level from the ground state. Okay, so now this is what the absorption spectrum. Now I'm talking about the emission spectrum. In emission spectrum, what will happen? So, idudha vandu again namma energy n is equal to 1. Idudha vandu n is equal to 2. Idudha vandu n is equal to 3. So, basic we can just say that in the electrons vandu excited state la vandu around 10 to the power minus 8 seconds. Avlo seconds da idu vandu anda excited state la irukum. And the state la irukumbodhu what it will do? It will just release the energy and it will come back. Ipo vandu in the level irundhu it will emit a photon which is having an energy h mu. Okay, so on the photon release panni konjan time illa. Okay, as I mentioned, on the excited state illa adu vandu it will be stay for hardly like 10 to the power minus 8 second. Okay, so appadina it will just release the energy and it will come to the lower level. Adha vandu emission spectrum. So idhula vandu energy levels oda value vandu same da agapore, and you can find it using this one. For hydrogen Z vandu 1 da, adanala da we are writing minus 13.6 divided by n square. Okay va? So now the thing is like we are going for in the wavelength we do. Okay, now for a hydrogen atom or let's say hydrogen like atom, what is exactly happening when it is moving from one energy level to the another energy level. And also one more thing is like in the emission spectrathila, there is no, I mean we can see that in the ground state, okay, in the ground state, fine, okay, in the ground state, I hope it is visible now, okay, in the ground state, what is happening, and the emission it is not possible from this energy level. Correct? This is the absorption, that's the emission. What is happening? In the ground state, n is equal to 1, nothing is happening, which means in the emission, n is equal to 1, it is not going to. Okay. Now the thing is like, for the hydrogen atom, we can say that when n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Okay, so it will go up to infinity. So the thing is like in emission spectrum, in the electronic in the first second stage, n is equal to 2 it can come to n is equal to 1. N is equal to 3 it can come to n is equal to 1. N is equal to infinity it can come to n is equal to 1. Okay, so on the time spectral series we will be call it as Lyman series. Okay, Lyman series. So the transition will be happening to NF it can be 2, 3, 4, etc. etc. Ni it has to be 1. Okay, it will be traveling from second, or n is equal to 2, n is equal to 3, n is equal to 4 to the first n1, which is equal to. Okay, now you can just find this 1 by lambda. What is going to be that? Minus 13.6 z square will be 1 divided by, or else we can go for Rydberg constant into 1 by nf square. The first transition will be from 2. Sorry. Okay, it will be from 2. So we can say this is going to happen. Okay, in the Rydberg constant into 1 by lambda will be in the Rydberg constant into 1 by 1 square minus 1 by 2 square. So generally I can just write it as 1 by lambda, which is equal to r into 1 minus 1 by nf square. So you can just put it as n is equal to 3, n is equal to 4, n is equal to 5. Okay, and these lines are coming under the UV region. Okay, idu kuda important da. These are coming under the UV region. In the equations ellame vandu important, and at least you should know what is going to be the maximum wavelength. Maximum wavelength na, it will be coming from the least transition, which means from n is equal to 2 to n is equal to 1 da idhula irukra, I mean adula da maximum wavelength irukum. So adu kuda you can just do it, you can just do the calculation. Next one, the Balmer. Okay, in Balmer series what will happen? Again in the transition irukku. Okay, transition irukku. So what is happening is nothing but all the lines, okay, all the lines will come to, okay, from infinity lirundha it has to come to n is equal to 2. Appadina nf will be 3, 4, 5, etc. Ni will be coming as 2. Appadina 1 by lambda I can write it as r into 1 by nf square, which means 1 by ni square, that will be always 2 square, minus 1 by nf square. For maximum wavelength you can put nf, which is equal to 3. This is the Balmer. Next one is Passion. So that will be happening to n is equal to 3. Purinjida. So this will be in the Balmer one, it is in the visible region. The rest all is coming in the infrared. Okay. Adukappuram in the Passion kappuram we have, I'll write it over here. So NF will be 4, 5, etc. Ni will be coming as 3. Again, you can just use this equation R into 1 by 3 square minus 1 by Nf square, which will be in the infrared region. Next is nothing but the bracket. Okay, so idhila vantha you can see Nf will be 5, 6 like that. Ni will be coming as 4. Again, 1 by lambda will be R into 1 by 4 square minus 1 by Nf square. Okay, and this is also coming in the infrared region. Last one is this fund. Okay, last one is fund. So for this one, you can again go for Nf will be coming as 6, 7, etc., etc. Ni will be coming as 5. Okay, and this will be coming under the region far from infrared region. Idu vande infrared da, idu kuda vande infrared da. So you guys should know, okay, you guys should know all these values, what is going to be Nf, what is going to be Ni. Also you guys should know which region it is coming. Okay, so first one will be in the UV region, Lyman, then visible, then infrared, again far infrared region. Okay, so this is the basic idea. Purinjida. So all these things, whatever I have written, make a note of it. You should know. And also in the maximum wavelength, when it is coming from the closest consecutive n values, which means if inge 2 na inga vandu 3 ah irukano, inga vandu 3 na inga vandu 4 ah irukano, aduvada vandu maximum wavelength. Okay, very good, very good, very good. So ipa vandu we are going for the calculation of recoil velocity while emitting the photon. So ipa vandu in the atom irukkiradhu, okay, idudha vandu nucleus, idhula vandu let us say in the outermost shell la vandu there is a electron. Okay va, so in the time la in the atom vandu rest la irukku, correct ada, in the atom vandu rest la irukku. Now what is happening in the electron, idu vandu important ana concept ah purinjukko. So ipo vandu in the electron ku enna aga pore, yes, it will be coming to de-excitation happening. So in the higher orbit la irundha it is coming to the lower orbit. Appadina again this is the nucleus and here is our electron. De-excitation happened. Okay, vada de-excitation. So we know that when an electron, okay, ipo vandu oru electron vandu higher energy state la irundha lower energy state la varapore, correct ah, idu vandu higher energy level la irundha lower energy level ku it is going to come. Appadina and the time la what is happening, it has to emit a photon. So ipo vandu in the photon will be emitted like this. So exactly we need to connect this with the recoil velocity of gun. What is exactly happening? When we are shooting, okay, the bullet will go forward and in the gun we will be get a velocity in the opposite direction. That's what we are calling recoil velocity. So when this electron is moving, or let's say it is de-excited to the lower energy level na, what is happening, in the photon is moving in this direction na, in the atom there will be a recoil in the opposite direction. Important concept da, everyone should understand. So initially in the atom vandu rest la da irukke, adukappuram what happened after we know that in the electrons vandu excited state la irukumbodhu adukku vandu it cannot stay for a long time, it can stay only for a very small time, adukappuram it will be coming back to the lower energy level. And the time la there will be a emission of photons. So in the emission happening direction la irundhu opposite direction la there will be a velocity which is having for the atom, adha vandu we are calling it as recoil velocity, exactly like the recoil of gun. Bullet moving forward, in the case la photon moving forward, and bullet gun vandu it is moving backward, in the case la in the atom vandu moving backward, correct ah? So now we can say that idhula vandu momentum of the photon adha vandu h by lambda. According to momentum conservation, we can say that this will be equal to mass of the atom into the recoil velocity. அப்படினா h by m lambda will be coming as the recoil velocity. So இப்போ வந்து you can also write in terms of energy as well. Okay, if you want you can just write in terms of energy also. ஏனா வந்து இந்த mv which is also equal to the change in energy divided by c. So v will be coming as E by mc. புரிஞ்சுதா? So இதுதான் வந்து next important ஆன concept which is coming under the chapter atom. Okay, and also when electron is jumping from any state to the ground state na adil irukra, I mean we know. Okay, I hope this is understood. Everyone has written this, yes or no? Okay, thank you guys, thank you so much. Actually today I have some health issues. Okay, enku vandu health avlo okay illa, I'm trying my best to complete it. Okay, adukku da even if you are giving some fire and things also அது ஒர்க் ஆகாது. எனக்கு வந்து இன்னைக்கு ஹெல்த் ப்ராப்ளம் தான், மென்டல் ப்ராப்ளம் எதுவும் இல்லை, ஹெல்த் ப்ராப்ளம் தான். தட் இஸ் த ப்ராப்ளம். ஓகே, ஸோ இப்போ வந்து we have understood about the recoil. Now as I mentioned, இந்த எனர்ஜி லெவல்ஸ் இருக்கு. ஸோ இங்கே இருந்து it is coming towards the ground stateனா from infinity to yes da not feeling well. Okay, so from infinity to in the electrons it can jump to different orbit levels, right? இப்போ வந்து இந்த ground levelக்குனா இதில் இருக்கிற possibilities, which means இது வந்து n is equal to 4, n is equal to 3, n is equal to 2, n is equal to 1 தான். கரெக்டா? அப்படினா we can say that இந்த ஸ்டேட்டில் இருந்து, okay, இந்த ஸ்டேட்டில் இருந்து it can straightly come to here. கரெக்டா? It can straightly come to n is equal to 1. Otherwise it can come to n is equal to 3, adukapram n is equal to 2, adukapram n is equal to 1. Also it can come like this. It can come straightly from 4 to 2, adukapram it can come like this. Also another possibility is, let us say it can come to this level, adukapram straight ippidi kuda it can travel. Okay, adinala we should get the number of possibilities of transition, and the possibilities will be, the number will be coming as n into n minus 1 divided by 2, which means for an electron jump down from n to ground state, and the possibility of having the transitions vandu n into n minus 1 divided by 2. Thank you da, thank you so much. Okay, so idudha we need to study after this, and I hope we have done almost everything coming under atom. Okay, so paravailla, even if you are feeling this chapter, okay, I can see that you people are also trying your best. I'm also trying my best. Ipo vande if you wanted to repeat the chapter nalum in the class appuram, you can just put me a comment in the same chapter vande, I can just again I can just do the same chapter, no worries, but make sure you are getting each and every concept from each chapter. Okay, idukku vande high weightage irukku. Thank you so much. So next one we can just go for the questions. Idhula kuda I have kept all the important topics, everything I have kept, so you can just go for this. Okay, so next one we are going for solving the questions. Ready ada? I hope everybody is ready for solving the questions. You guys also take care, because you guys are going to write the exam, not me. Drink a plenty of water, we'll get the energy. Okay, so yeah, so now first question, what is the ratio of circumference of a first Bohr orbit for the electron in the hydrogen atom to the de Broglie wavelength of electrons? Okay, so we need to get the ratio and having the same velocity as the electron in the first orbit of the hydrogen atom. So we need the ratio of 2 pi r divided by lambda. இதுதா வந்து we need it. 2 pi r divided by lambda. இதுக்காக very simple da. Lambda வந்து we know. Lambda வந்து h by mv da. In the 2 pi r we can also go for the what is our second postulate. Second postulate என்னடா? In the angular momentum வந்து nh by 2 pi da. So 2 pi r divided by nh by mv. Okay, so இதுதா வந்து circumference 2 pi r. So now you got the equation for both 2 pi r and lambda. Now can you make the relation? Now can you make the relation? N vanthu it is going to be 1. Okay, yena this is happening in the ground. Same velocity da. So adanala what is going to be the ratio? Quick you can give me the answer. Quick give me the answer. Quick give me the answer. Simple ana question already I have written over here. Idhula vandu n will be 1. Appadina h by mv da. We need the circumference to the lambda ratio. So both the case in the right hand side vandu same da. So adanala what is the answer we will be getting? We will be getting the 1:1 ratio. Very good, super. Now let us go for the next question. Hydrogen atom is excited from ground state to another state with the principal quantum number equal to 4, which means n is given as 4. Then the total number of spectral lines in the emission spectra will be. Again, we have just now only we have studied the relation. In the relation n into n minus 1 divided by 2. So now you can just put the value of n and tell me the answer. Yes, correct. Very good. So do this question right now. Very good. So idhula vanthu 4 into 4 minus 1 na 3 divided by 2. So it will be coming as 6. Hence option D is going to be the right answer. Correct? Got it? Yes. Okay. Hi Zuma. Now we are going for the next question. Okay. So this is indicating arrow mark only. Don't be get confused. The transition from n is equal to 4 to 3 in a hydrogen atom results in an ultraviolet region. Infrared radiation will be obtained in the transition from. So in the question what I want is like you guys have to think about it. Okay, you should think about the question. So ultraviolet region badala what we needed? We need infrared region. So appadina in the energy vandu reduce aganama illaya. Okay, think about it. In the energy vandu less aganama illa greater aganama. So of course vandu we know that very good. Yeah, very good. So n is equal to from 4 to 3 da. So ipa vandu you can just do the calculation and you can find it, or otherwise using common sense, or let's say using logic. Okay, using logic you can do this. So idhula vandu paakumbodhu n is equal to 4 to n is equal to 3 da. Correct? N is equal to 4 to n is equal to 3. Appadina what will happen? N is equal to 4 to 3 na adha vida energy less irukanum to come to the infrared region. Okay, yena energy oda equation we know. So adanala in the options paakumbodhu the energy will be even lesser than 4 to 3 will be coming as 5 to 4. So idoda concept vandu as I mentioned you should understand idukku vandu infrared ponomna adukku vandu energy again even lesser ah irukanum, adukaga da we can just go for the option 5 to 4. In which of the following system will the radius of the second orbit be minimum? Radius vandu minimum aganum. Correct? So idukaga you just need this relation. R is proportional to z square by n. In the same, because we have found this relation, right? Not z square. We have done R na R is proportional to n square by z. Correct? So அப்படினா you can just substitute. இதில வந்து n is going to be same. Okay, அப்படினா it is completely depending upon z. So which one is having the lesser z, that will be having the maximum r. So now you can just go for it. Very good, very good, very good. ஏனா z value வந்து atomic number வந்து it is greater for the magnesium. So அதனால answer வந்து option B. Next question. Calculate the principal quantum number for which the radius of the orbit of the electron in barium plus 3 would be equal to that of the ground state of electron in a hydrogen atom. Also compare the energy of the two levels. Okay. So idukku vandu first vandu we have to go for the radius. So on the radius we can say that it is proportional to again n square by z. Okay, energy kaga we can say that it will be coming as the ratio. Energy vandu it is nothing but minus 13.6 z square by n square. So idu use panni you can just find the answer. Hydrogen, and it is mentioned about the beryllium, right? So now you can do it. Yes, 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 very good. Check it again. Check it again. So first lerundu you have to find n value using that relation. R is proportional to n square by z. Okay. So idhula vandu it is given that the radius of the orbit of electron barium is equal to. Adanala I can say that R of beryllium which is equal to R of hydrogen. So idhula vandu we can just go for n square by z. Okay. Which is equal to n square divided by z. Okay. So idilirunta you can just find the n value. Same energy state da. Okay. Equal to ground state. So in the value vandu 1 divided by atomic number of hydrogen vandu 1 da. So appadina in the n square will be coming as the atomic number of beryllium. Okay. So appadina n will be coming as 2. Okay. So that is what we need to do in this case. Now I am going to just ask the easy chemistry questions. Okay. Now I just wanted to ask you what is the energy. Okay. Compare the energies to two states. Okay. So adanala you should give me what is going to be the ratio of. Okay. In the beryllium divided by hydrogen, in the ratio, what is going to be that ratio? The option la illa aanalum we have to find it. So what is going to be that ratio? What you will be getting? Can you go for it? Idhila vandu said we got it as 2. Appadina you should find what is going to be the ratio of beryllium divided by energy of beryllium divided by hydrogen. Very good, very good. And the ratio vandu it will be coming as 4 by 1. So simple irukku. We know energy of beryllium divided by energy of hydrogen. Adula vandu paakumbodhu you can see that z square divided by idu vandu beryllium n of beryllium square divided by, when it comes to here we can just say that here we will be having the nh square divided by zh square. So in the part vandu 1 aga pore, so you will be getting 4. Okay, 4 by 1 da idoda answer. So n vandu 2. And now the potential energy of the electron in the hydrogen atom is given as potential energy minus E square 4 pi epsilon naught R. Then what is the kinetic energy? Simple, quick, you can give the answer. I was born in 2009 and this question came into... Let it be a lucky question. The same question should repeat for your NEET 2026 also. But you will be writing in 2027, right? So இப்போ வந்து kinetic energy quick potential energy we got it அப்படினா kinetic energy will be and the relation என்ன potential energy na 2 times kinetic energy. Okay, so you can go for minus u by 2 is going to be k. So kinetic energy vandu always positive ஆக போறே. So right now the thing is like you can just remove option C. Correct, அதுக்கு வந்து நெகட்டிவ் இருக்கு. So அதனால this is not possible. Kinetic energy na positive da. Okay, and equal value it is not possible. So அதனால we can just go for by 2 na this is going to be the answer. Okay, potential energy is given, kinetic energy da வேணும். Okay, so kinetic energy and potential energy relation வந்து இதுதா. So minus of this is going to be the thing. So you will be getting E square by 8 epsilon naught R. The wavelength of the first line of Lyman series, wavelength of first line of Lyman series is lambda. The wavelength of the first line in the Balmer series. Okay, very simple. You can just substitute in the equation. What is the equation? 1 by lambda which is equal to R into 1 by Lyman na 1 square minus 1 by 2 square. Okay, so by doing this what you will be getting R into 1 minus 1 by 4. Appadina it will be coming as 3R by 4. Next one the Balmer da and idoda value it is given as lambda. Okay, sorry, idoda value it is 3R and it is given adoda wavelength which means 4 by 3R one the lambda da. Next one the Balmer oda wavelength R into 1 by 4 minus 1 by 9. Okay, so appadina idu vandu R into it will be coming as 9 minus 4. Appadina it will be coming as again 5 and this will be coming as 36. Okay, ipo vandu you can just go for this ratio. Okay, idoda ratio na lambda b which means Balmer series which will be coming as 3R by 4 divided by, or let's say we can just go for 5R 36. Okay, so idhula vandu R got cancelled. Okay, now the thing is like you can just sort it out. What will happen? 36 into 3 divided by 4 into 5. Can you do it? 4 into 5 vandu 20. Okay, what is 36 into 3? 108 will come. Okay, so this into lambda L na lambda b paakumbodhu we can say 108 divided by 20 into lambda L ku vandu I'm going to give a value that is lambda. Now you can just simplify this. So by simplifying this what you will be getting? You will be getting 27 by 5 lambda. Hence option A is going to be the right answer. Okay, so now we have done few questions also. Next, as the orbit number increases, which means n increases, the distance between two consecutive orbits in an atom or ion having single electron, what will happen? So idu vanta simple ah irukku. Okay, so we know that in the Rn na some constant value usually vantu we will be mention it as a naught. Okay, we know n square by z da in the Rn. Appadina consecutive சொல்லும்போது I am just taking n plus 1. A naught vandu again constant da. Idu vandu n plus 1 the whole square divided by z. Ipo vandu you should do n plus 1 minus Rn. So now you can just check what is happening on the right hand side. Can you do it? Very good, very good. So idhula vandu you can go for a naught into n square plus 2n plus 1 divided by z minus a n square divided by z. So in the two terms vandu it will be cancelled. So you will be getting a naught by 2 into 2n plus 1. So by seeing this equation, when n increases now, obviously and the distance of separation kuda increase agapore. Very good. Now, the ground state energy of a hydrogen atom. Okay, ground state when n is equal to 1 agra point illa energy vandu minus 13.6 electron volt da. So அந்த டைம்ல இருக்கிற kinetic energy and potential energy தான் தேவையா இருக்கு. Simple da, simple. Total energy is given. What is going to be the kinetic energy? What is going to be the potential energy? So இதோட half value da, correcta? In the u by 2 da in the, correcta? Yes, energy, total energy. அப்படினா we should multiply this. So 2 into minus 13.6 electron volt வந்து potential energy, and இதோட value வந்து same தான், ஆனா வந்து positive ஆ இருக்கணும். Correcta? Very good, very good, very good. So that is going to be the answer for this question. Okay, so இப்போ வந்து we have done with the what to say atom also. Now let us go for the nuclei. Okay, so in nuclei chapter, first of all we should go for the, or let me do one thing. Okay, so in the chapter வந்து we can just discuss on some other day, because I too don't have the energy and I want the complete, I mean you should get the nuclei chapter வந்து easy da, அது வந்து small chapter da, ஆனாலும் வந்து we should give the what to say அதுக்கு தேவையா இருக்கிற value வந்து we have to give, correct? So அதனால let me just do this chapter on some other day, because again I can't just spend for 1.5 hours. Okay, I'll be completely drained. Okay, so then let us do one thing. In the chapter வந்து we can just take on some other day. As I mentioned, illena recorded session irundhalum I will do it. Okay, in the live la if not possible na recorded session I will be just placing it. No worries about it. Idhula vandu questions practice irukum, and also in the next coming week la, I mean in the week la, okay, in the week la fine nucleon semiconductor vandu I will handle in the next chapter, I mean next class. Let me just do that. Fine. So the I mean we can just handle in 4 to 5 hours also. It will work. And also idoda questions practice vanta we will again do it on this week itself. Together we will be solving the question. Ana marakkama you guys have to come for the question practice session. Yena listening the class doesn't make anything, especially when it comes to physics. Okay va? So adanala everybody has to, Zener diode irukku, it is there da. Don't skip all the topics. LED irukku, photodiode irukku, Zener diode irukku, everything is there in the syllabus. So yes da, yes it is there. Okay, so what I'm, yes da, yes Akash, very good. Okay, so ipa vandu what I'm going to tell is, and the problem solving session la I have planned for many questions, ஆனா வந்து நீங்க வந்து கொஞ்சம் கூட fast ஆகணும். So அது வந்து as I mentioned, அது வந்து ஈஸியா இல்ல. Okay, இந்த question practice quick-ஆ 1 minute இல்ல 2 minute இல்ல பண்றது வந்து அவ்வளோ ஈஸியான விஷயம் கிடையாது. But I want you people to come. Beginning இல்ல maybe you will take 3 minutes. ஆனா அந்த time வந்து reduce ஆகணும்ல, அதுக்காக we should do more questions. Okay, illena we cannot crack the NEET exam. Just think about taking 4-5 minutes for one question. Then you can't even complete 10 questions in physics. Yena vandu biology ku appuram da you will be taking chemistry, adukku appuram da physics ku neenga vandu priority e kodukra. So adanala in the 5 minutes vandu one question hardly vandu, if you are using the time properly, 5 minutes vandu one question ku na you cannot even solve 10 questions in physics. Adanala da I'm telling you, make sure you people are solving the question continuously. Next class la vandu sharp 1 or 1.5 minutes da I will give you for question. Okay. Okay, so sure I will teach da, don't worry. So on the session la join panniko. Next day la vanda I hope I'll come with an energy packet. So I hope I can I can connect more with you people. Innekku vanda complete I can't even stand properly. So adanala da I know the energy level was little less, but paravaillada, we can just handle these 2 chapters in the next class. Also, as I mentioned, ipo vandu in the chapters la in the nucleon dual nature la vandu, if you have felt like any confusion, ana vandu ma'am I don't want to disturb you ma'am, adanala da I didn't ask nalum paravailla, in the doubt la, I mean in the comment box la you can just raise your doubt. Adu vandu as I mentioned, next class la illana I will record the session and I will give you, no worries. As I mentioned, compromise neenga vandu compromise pannada. Okay, if you want the same lecture nalum paravaillada, I will do it, not today but I can do it in this week itself. Ana vandu don't compromise from your end, yena we have hardly 53 days da irukku. Adila vandu it is not easy for us to crack a good score. In the 600 plus vandu illana 620 plus vandu avlo easy ana vishayam kedaiyadu. You should get a proper guidance, plus you guys should get a proper guidance, plus practice. Okay, especially as I mentioned, when it comes to physics practice vandu avlo mukkiyam. You cannot skip the questions, you cannot skip the hard questions, ellame vandu we have to practice. Initially there will be a lot of confusions, it is going to be time consuming. Enakke theriyum yena there are many students even they don't know mathematics. They are also initially they used to take 10 minutes, ana vandu exam ku they have finished even less than 1 minute, including the maths problems. Okay, and the complicated maths irukra problems kuda yen students vandu simple ah solve panniyarka. Ana what I want from you people is அது வந்து ஈஸியாக இல்லை, அதோட இம்பார்ட்டன்ஸ் புரிஞ்சுக்கோ அண்ட் கம் வித் அ ப்ராப்பர் கிளாரிட்டி. இந்த கொஸ்டனுக்கு வந்து எவ்வளோ டைம் ஐ எம் யூஸ் டு டேக், ஓகே, அது வந்து எப்படி ஐ கேன் டிக்ரீஸ், அதுதான் வந்து நம்ம கீ. நீட்டில் இட் இஸ் நாட் ஆல் அபவுட் ஐ ஹாவ் ஸ்டடீட் மேம், ஸ்பீட் ஆல்சோ மேட்டர்ஸ், ஆக்குரசி ஆல்சோ மேட்டர்ஸ். ஸோ அதனால மறக்காமல் எவ்ரி ஒன் ஷுட் ப்ராக்டிஸ் கொஸ்டின்ஸ். ஓகே, அண்ட் ஐ ஹோப் எவ்ரி ஒன் இஸ் டூயிங் வெல். Okay, NEET preparation வந்து at least in the last 2 months la and what to say, if you are working really hard na, I am telling you, you can make it. Paravailla Manivel, we are going to wind up the session. Okay, next week not next week why I am saying next week. Okay, in the week we will be having physics classes. Adla vandu we will be handling nuclei and semiconductor. So you can just attend that session. In the class mudinjadukku appuram you can watch the lecture also. Okay, Paravailla Manivel, it was already over. Okay, usually vandu we used to take 5 hours of lecture, ana vandu inniki koncham time da we have spent. Okay vada. Okay, so thank you so much guys. Yes, Hari, hi. Class mudinjadukku appuram ivlo students are coming. Yes, fine. Ana vanta try to finish, even if you are comfortable, keep it in 1.5x. Adu kuda will work because yena vanta we don't have much time. Okay va. Of course, Amuda, of course, once you have done with the revision, na, go straightly for the questions, okay? Ipo vandu in the revisions and detailed classes vandu it is thevaiya irukku. Aanalum vandu if you are confident na, straightly go for questions da. Don't even think about anything else. Okay? Okay. Purinjuda everybody? Of course, Hema, of course. Thank you so much. Okay, Manivel, I understood. No worries. In the class mudinjadukku appuram you can just watch the lectures. Also, mudinja in the live session, like even if you are late also, try to come and join. Hey gamer da, I am ready to take the Zener diode. Let me just schedule the class. Adila vandu Zener diode da major topic. You don't have to worry. Okay, Zener diode mattu illa, in the LED, photo diode, everything we will cover. Okay. So mudinjana you people have to try to come for the live session. Yena adu vandu koncham kuda interactive ah irukum. Recorded sessions paakumbodhu it will be quiet, you know, you will become little lazy, and definitely in the live la irukra interactions irukum. After live if you are watching na adu vandu avlo interactive aga maata. So adinala I am telling you, so please come to live session. எல்லா டேஸ்லுமே இந்த செஷன்ஸ் வந்து 4 PM தான். நெக்ஸ்ட் வீக்கில் கொஞ்சம் சேஞ்ச் இருக்கும். மார்னிங்கில் தான் we are planning for the sessions. So மார்னிங்கில் வந்து if you are just free now, you can just attend the sessions. Okay? Okay? Class over, Harry, class over. Okay? Fine. So guys, stay safe and proper sleep paniko. Next one, you have to revise these 2 chapters. Next 2 chapters we will cover in the next class. Don't worry, we will complete each and every concept, each and every questions, everything we will do it. And question practice session la marakama join panikoda. I don't want any people to miss that session. Okay? Yena physics especially physics avlo importance in the what is a question practice pandrathu avlo important da. Adinala da I'm telling you. Okay, fine, Manivel. You can just attend in the morning classes. Okay, va? Okay, done. So, see you guys. We will meet with some other topic, not some other topic, nuclei and semiconductors. Okay, in the next class. So, bye, everybody. Bye, Hema. Okay, lots of heart. Okay, bye. Thank you so much for the support and care, guys. Thank you. Of course, I'll take rest. Thank you. Questions practice we will let you know the schedule. Okay, once we have done with the proper concept classes, adikapram we are planning for some what is a question practice, only question practice. And the question, and the session marakama, if you are confident in the concept na, in the question practice join panniko. Okay, thank you so much.